Yes, good morning. So yesterday we were discussing about this orbit, we stopped here. So I got a different picture today, so it is more clear here. So the types of orbits, so the first by inclination they have given. So the equatorial orbit, one which flies just above the equator, okay, and polar orbit is that it goes from poles, it revolves around the poles, and then we have this inclination, inclined orbit. It does not have this it is like it can be any slanting, any side, any way it can move around, so that is inclined orbit. And based on the altitude we saw, that is low earth orbit, around 100 to 160 to 2000 kilometer they have given, and medium earth it goes up to 5000 to 10,000 kilometers, and geostationary orbit it goes up to 36,000 kilometer. And by shape also, so circular orbit will have a normal circular orbit, and elliptical orbit where earth will be at one of the foci. So these points, extreme points, we call it as foci or focus, okay. So even earth revolves around the sun in this elliptical orbit, so it is not circular orbit. The revolution of the earth around the sun is not a circular orbit, it is an elliptical orbit, and sun is at one of the foci. Similarly, some satellites we place in the elliptical orbit. And we saw other two types, that is sun synchronous and geosynchronous. So geosynchronous is that it is inclined and it is placed at the height of 36,000 kilometer. It is a type of geostationary orbit only by altitude, but it will be not above the equator, it will be placed in an inclined orbit. But the sun synchronous is an a type of a polar orbit. So even sun synchronous satellites revolve around the earth in this polar, from pole to pole hinge revolve ಆಗುತ್ತೆ, and that is relative to sun. Relative to sun ಅದು fixed point ಅಲ್ಲಿ ಇರುತ್ತೆ, right? I told you, right? It passes the same place at the same time every day. Bangalore 12 o'clock pass ಆದ್ರೆ every day 12 o'clock it will pass Bangalore. So it is relative to sun, a constant position relative to sun. And whereas geostationary, it will be it looks like it is there in a fixed position in the sky. ಅಂದ್ರೆ ಅದು ಮೂವ್ ಆಗ್ತಿಲ್ಲ ಅಂತ ಅನ್ಸುತ್ತೆ. Why? Because the revolution of the orbit is equals to the rotational time taken by the earth. So 24 hours, even the revolution of the orbit will of the satellite will take 24 hours. So are we clear with the types of orbits? So you can write now. First, based on first you can write based on altitude. So low earth orbit, so the range is around 160 to 2000 kilometer above the earth, and our international space station is in the low earth orbit only, okay. And then medium earth orbit 5000 to 10,000 kilometer. This GPS system, global positioning system. So GPS is placed in the medium earth orbit, which helps in finding out the locations, right? GPS system is placed in the medium earth orbit. So next you can write geostationary, altitude is 35,000, approximately 36,000 you can write, approximately 36,000 kilometer above the earth. After that you can write this point, satellites in geostationary orbit, satellites in geo circle earth above the equator. circle earth above the equator, taking 23 hours 56 minutes, 23 hours 56 minutes by traveling at the same rate, as the rotation of the earth. This makes satellites in geostationary orbit. This makes satellites in geostationary orbit appear to be stationary over a fixed position from the earth. So, mostly telecommunication satellites will be placed in geostationary orbits. You can write telecommunication satellites. And then you can write the types by inclination. So, the first one is equatorial orbit. You can write the orbit is just above the equator, that is all. So, equatorial orbit is nothing but your geostationary. It just they have differentiated in by inclination and by shape and by altitude. So, it is just the orbit is just above the equator. Next you have polar orbit, that passes polar orbit next, you can write passes near the earth's pole So, polar orbits will always be at a very low height only. So, polar orbit is placed in the low earth orbits only, which is going over the earth's poles. It will be placed at altitude of 160 to 2000 kilometers only. So, it is a type of your low earth orbit. Okay. So, polar orbit is a type of low earth orbit. And then inclined orbit you can write. It is a plane inclined at some angle to the equator. Plane inclined at some angle to the equator. After this you can write sun synchronous orbit. Sun synchronous orbit. So, under that they are synchronous with the sun. That is, they always appear to be in the same fixed position relative to the sun. Sun synchronous orbit. Okay, sun synchronous orbit. So, they are synchronous with the sun, that is they always appear to be in the same fixed position relative to the sun. Hence, the satellite hence the satellite will always observe a point, on the earth, on the earth, as if constantly at the same time of the day. Always observe a point on the earth as if constantly at the same point on the earth. Sun synchronous will be in the low earth orbit only. Sun synchronous will be in the low earth orbit. No, inclined will be in the geostationary. Okay. So after sun synchronous, you can write down geosynchronous. Geosynchronous. It is a type of geostationary orbit. It is a type of geostationary orbit, but it is inclined to some angle. So, some angle to the equator. So, it will not be just above the equator, it will remain like it is an example for inclined and geostationary orbit. So, the shape will be like inclined, but the height will be around 36,000 kilometer for geosynchronous. Okay. So, these also like they appear to be same stationary in the sky, like how geostationary satellites appear stationary. Geosynchronous also appear to be stationary, just that the angle is different. In geostationary, the angle will be same, like 0 degree, like it will be just above the equator. But geosynchronous will have a inclined plane. That is all the differences between geosynchronous and geostationary. Okay. Are we clear? So, inclination, we have this equatorial orbit, it will be just above the equator. So, geostationary will also be just above the equator, that is at the height of 36,000 kilometer. And then we have polar orbit, which goes around the earth's pole, and it will be placed in the low earth orbit only. And even sun synchronous will be placed in the low earth orbit only, it will go like towards the poles only. Okay, even sun synchronous. And then we have this inclined orbit. So, geosynchronous will be in the inclined orbit, and it will be placed at the height of 36,000 kilometer. Okay. So, ishtu gottidre saku. These are the circular elliptical orbit is not required or not important. So, next we have the types of launch vehicles that India has. So, rockets work in the which principle, under which principle? Yeah, Newton's third law. So, rockets always works under Newton's third law, that every object has like every action has equal and opposite reaction. So, the fuel is burnt and it pushes the rocket upwards, right. So, the gas is let out, and in reaction to that the rocket will go up. So, that is the principle behind the rockets, how rocket will take off. So, rocket will be made up of different stages actually. So, only the payload, andre ivaga top most part iruttalla, illi payload na ittirtare, only payload will go and orbit in the above the earth. So, all of this it will fall off eventually as it takes off. ಬಿಕಾಸ್ ಇವಾಗ ಹೈಟ್ ಹೋಗ್ಬೇಕಂದ್ರೆ ಏನು ತುಂಬ ಕಡಿಮೆ ಮಾಸ್ ಇದ್ದರೆ ಜಾಸ್ತಿ ಹೈಟ್ ಹೋಗುತ್ತೆ ಆ್ಯಂಡ್ ದ ಸ್ಪೀಡ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ಮೋರ್. But if it is heavier, then it will be very difficult for the rocket to take off itself. So it is better if we want to go longer heights, or if you want to go to other other planets and all of that, interplanetary missions, or go to moon, the rocket has to be very light in weight. So that is how it evolved all of, because we wanted lighter rockets to take off, so it evolved. So initially the first one was the SLV, Satellite Launch Vehicle. So ನಾವು ನಿನ್ನೆ ನೋಡಿದ್ವಿ ದ ಟೈಮ್ಲೈನ್ ನೋಡಬೇಕಾದ್ರೆ ಅಲ್ವಾ. ಸೊ ಇಂಡಿಯಾ 1979 ಅಲ್ಲಿ ಇಟ್ ಲಾಂಚ್ಡ್ ಇಟ್ಸ್ ಫಸ್ಟ್ SLV ಅಂತ, ರೈಟ್, ಸ್ಯಾಟಲೈಟ್ ಲಾಂಚ್ ವೆಹಿಕಲ್. ಸೊ ಸ್ಯಾಟಲೈಟ್ ಲಾಂಚ್ ವೆಹಿಕಲ್ ಅಲ್ಲಿ all the 4 stages, so it was divided into 4 stages and all of it had solid fuel. Okay, all of this had solid fuel. It was 4 stages and payload was just 40 kgs. Payload andre top most part ಏನು orbit ಅಲ್ಲಿ ಹೋಗಿರುತ್ತೆ, that we call it as payload. So payload was just 40 kgs of the SLV. So the satellites was very smaller in size. It had to be smaller in size because ನಮ್ಗೆ ಅವಾಗ ಅಷ್ಟು ಟೆಕ್ನಾಲಜಿ ಇರಲಿಲ್ಲ ಟು ರೆಡ್ಯೂಸ್ ದ ಫ್ಯೂಯಲ್ ವೇಟ್. ಸೊ ಫ್ಯೂಯಲ್ ವೇಟ್ ಕಡಿಮೆ ಆದರೆ ನಾವು ಪೇಲೋಡ್ನ ಜಾಸ್ತಿ ಮಾಡ್ಬೋದು, ಅವಾಗ ರಾಕೆಟ್ ಈಸಿಯಾಗಿ ಟೇಕ್ ಆಫ್ ಆಗುತ್ತೆ. So this was the first, and they continued using SLV till the year of 1983. Then after that they went to this ASLV. So ASLV is Augmented Satellite Launch Vehicle. So idralli 5 stages ittu. This had 5 stages. This was also again all solid fuel. It had all solid fuel idralunu. So weight ಜಾಸ್ತಿನೇ ಇತ್ತು, but they increased the payload here. Payload bandi almost 150 kgs ಆಯಿತು. So the payload was 150 kgs in Augmented Satellite Launch Vehicle. So ಇದನ್ನ 1994 ವರೆಗೂ ಯೂಸ್ ಮಾಡಿದ್ರು. Okay, 1994 ವರೆಗೂ they used ASLV. After that India indigenously did this Polar Satellite Launch Vehicle, PSLV. So Polar Satellite Launch Vehicle ಬಂದಾಗ like fuel ಏನಾಯಿತು, they did a mix there. So ಬರೀ solid ಯೂಸ್ ಮಾಡಿದ್ರೆ then the weight of the total rocket will be more, but we want to increase the payload here. Payload increase ಮಾಡಬೇಕಂತ ಏನು ಮಾಡಿದ್ರು, this was 4 stages and it had 2 solid stage and 2 liquid stage. 2 solid and 2 liquid stage ಇತ್ತು ಇದರಲ್ಲಿ, ಅಂದರೆ ಆಲ್ಟರ್ನೇಟ್, ಫಸ್ಟ್ ಸಾಲಿಡ್ ಸ್ಟೇಜು, ಅದಾದಮೇಲೆ ಲಿಕ್ವಿಡ್ ಫ್ಯೂಯಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು. ಲಿಕ್ವಿಡ್ ಫ್ಯೂಯಲ್ ಅಂದರೆ ಲಿಕ್ವಿಡ್ ಹೈಡ್ರೋಜನ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು ಬೇಸಿಕ್ಲಿ. ಓಕೆ, ಲಿಕ್ವಿಡ್ ಹೈಡ್ರೋಜನ್ ಆ್ಯಂಡ್ ಲಿಕ್ವಿಡ್ ಆಕ್ಸಿಜನ್ ದೇ ಯೂಸ್ ಟು ಯೂಸ್. ಆ್ಯಂಡ್ ದೆನ್ ಥರ್ಡ್ ಸ್ಟೇಜ್ ವಾಸ್ ಅಗೇನ್ ಸಾಲಿಡ್ ಆ್ಯಂಡ್ ಫೋರ್ತ್ ಸ್ಟೇಜ್ ವಾಸ್ ಲಿಕ್ವಿಡ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈ ಫ್ಯೂಯಲ್ದು ವೇಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ದ ರಾಕೆಟ್ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಮೋರ್ ಪೇಲೋಡ್. ಸೊ ದ ಪೇಲೋಡ್ ವಾಸ್ ಇನ್ಕ್ರೀಸ್ ಟು 3250 for low earth orbit. Low earth orbit ge it was 3250 and for polar orbit it was 1600 kgs payload and for geosynchronous it was 1400 kgs. ಯಾಕಂದರೆ ಇದು ತುಂಬ ಹೈಟ್ ಹೋಗ್ಬೇಕಲ್ಲ. ಸೊ geostationary earth orbit ge, so it has to go to a height of 36,000 kilometers. So the payload was less, but they achieved 3200 kilometers for the low earth orbit ge hogokke. And then this Chandrayaan 1 and Mangalyaan mission to the Mars, they used PSLV rockets only. Okay, they used PSLV. And next we have this GSLV, Geosynchronous Satellite Launch Vehicle. So building this GSLV was India did not have that technology, using they introduced something called as cryogenic fuel. So this technology India did not have at that time. ಈ ಟೆಕ್ನಾಲಜಿ ಯಾರ ಹತ್ರ ಇತ್ತು ಅಂದರೆ ರಷ್ಯಾ ಹತ್ರ ಇತ್ತು ಆ್ಯಂಡ್ USA. So at that time our relation with USA was not that very well. Around, it was around 1970s or something. So it was not that good, and Russia was willing to help us. But ಈ ಟೆಕ್ನಾಲಜಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬಾರ್ದು ಅಂದ್ಬಿಟ್ಟು USA ಏನು ಮಾಡ್ತು, ಸ್ಯಾಂಕ್ಷನ್ಸ್ ಹಾಕ್ತು ರಷ್ಯಾ ಮೇಲೆ. ಸೊ ರಷ್ಯಾ ಕುಡಂಟ್ ಡೈರೆಕ್ಟ್ಲಿ help India in transferring this technology. There was one movie that came also, Madhavan, I forgot that, Rocketry, yes, the Nambi effect. So in that movie they have shown that, he was the person like who, built this GSLV rocket. So ಏನು ಮಾಡಿದ್ರು, ಟೆಕ್ನಾಲಜಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಿರಲಿಲ್ಲ, ಬಟ್ ದೇ ಬಾಟ್ ಸಮ್ ಆಫ್ ದ ಪಾರ್ಟ್ಸ್ ಫ್ರಮ್ ರಷ್ಯಾ ಟು ಇಂಡಿಯಾ. ಸೊ ವಾಟ್ ದೇ ಡಿಡ್ ಇಸ್ ದೇ ರಿವರ್ಸ್ ಇಂಜಿನಿಯರ್ಡ್ ಆ ಪಾರ್ಟ್ಸ್ನ ಇಟ್ಕೊಂಡು. ದೇ ಡಿಡ್ ನಾಟ್ ಹ್ಯಾವ್ ದ ಟೆಕ್ನಾಲಜಿ, ದೇ ಡಿಡ್ ನಾಟ್ ಗಿವ್ ಹೌ ಟು ಬಿಲ್ಡ್ ದಟ್, ರಷ್ಯಾ ಕೊಟ್ಟಿಲ್ಲ ಅದನ್ನ. ನಾವು ಆ ಪಾರ್ಟ್ಸ್ನ ಇಟ್ಕೊಂಡು ವಿ ರಿವರ್ಸ್ ಇಂಜಿನಿಯರ್ಡ್ ಆ್ಯಂಡ್ ಬಿಲ್ಟ್ ದ GSLV ರಾಕೆಟ್. ಬಿಕಾಸ್ ಕ್ರಯೋಜೆನಿಕ್ ಇಂಜಿನಲ್ಲಿ ದೇ ಯೂಸ್ liquid, again they use the liquid fuel only, but it is stored at a very low temperature, like around -150 degrees Celsius ಗೆ ಆ ಲಿಕ್ವಿಡ್ ಫ್ಯೂಯಲ್ನ ಸ್ಟೋರ್ ಮಾಡ್ತಾರೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ದ ಫ್ಯೂಯಲ್ದು ವೇಟು ಇನ್ನೂ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಇನ್ಕ್ರೀಸ್ ದ ಪೇಲೋಡ್. ಸೊ ಪೇಲೋಡ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೋದು ಅಂತ ಈ ನಾವು ಫ್ಯೂಯಲ್ ಮಾಸ್ನ ಕಡಿಮೆ ಮಾಡಬೇಕಾಗಿತ್ತು. ಸೊ ದೇ ಯೂಸ್ಡ್ ಕ್ರಯೋಜೆನಿಕ್ ಇಂಜಿನ್ ಇನ್ ದ GSLV. So here in GSLV it had 3 stages. So the first stage was solid fuel only, because first stage of solid fuel ಏನಕ್ಕೆ ಬೇಕು ಅಂದರೆ, ಇಂಪಾರ್ಟೆಂಟ್ ಏನಕ್ಕೆ ಆಗುತ್ತೆ ಅಂದರೆ, ಇಟ್ ನೀಡ್ ಇನಿಷಿಯಲ್ ಥ್ರಸ್ಟ್. ಬಿಕಾಸ್ ಆ ಏರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ನ ಅಪೋಸ್ ಮಾಡಿ ದ ರಾಕೆಟ್ ಹ್ಯಾಸ್ ಟು ರೇಸ್ ಅಪ್ ಅಲ್ವಾ. ದ ಫಸ್ಟ್ ಸ್ಟೇಜ್ ಶುಡ್ ಬಿ ಸಾಲಿಡ್ ಬಿಕಾಸ್ ಇಟ್ ನೀಡ್ ಮೋರ್ ಎನರ್ಜಿ ಫಾರ್ ದ ರಾಕೆಟ್ ಟು ಲಿಫ್ಟ್ ಆಫ್. But once it is lifted off, it can easily overcome that air resistance. So in the later stages, we can use the liquid fuel. So the second stage was liquid fuel, and third stage was cryogenic. ಕ್ರಯೋಜೆನಿಕ್ ಅಂದರೆ ಲಿಕ್ವಿಡ್ ಫ್ಯೂಯಲ್ನೇ ಅಟ್ ಅ ವೆರಿ ಲೋ ಟೆಂಪ್ರೇಚರಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇಲ್ಲಿ ಆಬ್ವಿಯಸ್ಲಿ ಪೇಲೋಡ್ ಮತ್ತೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ದೇ ಯೂಸ್ಡ್ 6,000 kgs ಫಾರ್ ಲೋ ಅರ್ತ್ ಆರ್ಬಿಟ್ ಆ್ಯಂಡ್ ಅರೌಂಡ್ 2,200 kg ಫಾರ್ ಜಿಯೋಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್. ಓಕೆ, ಸೊ ದ ಪೇಲೋಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದೆ. ನಾವು ಫ್ಯೂಯಲ್ದು ಏನು ವೇಟ್ ಕಡಿಮೆ ಮಾಡ್ತಾ ದ ಪೇಲೋಡ್ ಇಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ರೈಟ್. ಸೊ ಈ GSLV ಇಟ್ಕೊಂಡು ದೇ ಲಾಂಚ್ ದಿಸ್ ಚಂದ್ರಯಾನ್ 2. GSLV ವಾಸ್ ಯೂಸ್ಡ್ ಇನ್ ಚಂದ್ರಯಾನ್ 2. ಓಕೆ, and then later we built this GSLV Mark 3 which was used in Chandrayaan 3 that was recently launched. So Chandrayaan 2 bandi failure ಆಯಿತು. It did not soft land on the moon, it crashed in 2019. And 2023 they launched this Chandrayaan 3, adu land ಆಯಿತು. So they used GSLV Mark 3 in Chandrayaan 3. So here also we have similar only, like first solid stage, ಆಮೇಲೆ ಲಿಕ್ವಿಡ್, ಆಮೇಲೆ ಕ್ರಯೋಜೆನಿಕ್, ಇವನ್ GSLV Mark 3 ಅಲ್ಲಿ. ಬಟ್ ಪೇಲೋಡ್ ಒಂದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಇಲ್ಲಿ, ಅರೌಂಡ್ 3,500 to 4,000 kg payload. Payload will slightly increase here in GSLV Mark 3. So right now we are using this GSLV Mark 3 only, or LVM ಅಂತಾನೂ ಕರೀತಾರೆ ಇದನ್ನ, ಲಾಂಚ್ ವೆಹಿಕಲ್ Mark 3 ಅಂತ. And then so now they are developing even more more technologies, because ಇವಾಗ ನಾವು small satellites na launch ಮಾಡೋದಕ್ಕೆ we are planning to build this small satellites. After this SpaceX came up with Starlink project. They are planning to send around 42,000 satellites, because that will provide internet even to the remote areas anta. Andre entire earth gene internet sigbeku, that is the project of Starlink. Okay, ಸೊ ಅದೇ ಥರ ನಾವು ಇವಾಗ ಇವಾಗ ನಾವು ಇಂಟರ್ನೆಟ್ಟಿಗೆ ಏನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಯೂಸಿಂಗ್ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್. ಬೇಸಿಕಲಿ ವಿ ಹ್ಯಾವ್ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್. ನಾವು ಅದನ್ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ ಒಂದು ಸೈಟ್, ಅಂದರೆ ಇವಾಗ ಈ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ಗೆ ನಮ್ಗೆ ಇಂಟರ್ನೆಟ್ ಬೇಕು ಅಂದರೆ ವಿ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದಸ್ ರೌಟರ್, ಅಲ್ಲಿಂದ ಒಂದು ವಯರ್ ಇರತ್ತೆ ತಾನೆ. ಸೊ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್. ಸೊ ಅದು ನಮಗೆ ಇಂಟರ್ನೆಟ್ನ ಪ್ರೊವೈಡ್ ಮಾಡುತ್ತೆ. ಸೊ ವೈರ್ಲೆಸ್ ಇಂಟರ್ನೆಟ್ ಇದು. ಸೊ ಓನ್ಲಿ ಸ್ಯಾಟಿಲೈಟ್ ವಿಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರೊವೈಡ್ ಅಸ್ ಇಂಟರ್ನೆಟ್. ಸೊ ಅದು ಮಾಡೋದಕ್ಕೆ 42,000 ಸ್ಯಾಟಿಲೈಟ್ಸ್ ಬೇಕು, ಆ್ಯಂಡ್ ಆಲ್ ಆಫ್ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ಇನ್ ದ ಲೋವರ್ ಅರ್ತ್ ಆರ್ಬಿಟ್. ಸೊ ದ ಸೈಜ್ ಆಫ್ ದ ಸ್ಯಾಟಿಲೈಟ್ ಶುಡ್ ಬಿಕಮ್ ಸ್ಮಾಲ್. ಸೊ ವಾಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್ ನೆಕ್ಸ್ಟ್ ಇಸ್ ಬಿಲ್ಡಿಂಗ್ ದಿಸ್ ಸ್ಮಾಲ್ ಸ್ಯಾಟಿಲೈಟ್ ಲಾಂಚ್ ವೆಹಿಕಲ್ಸ್. ಅಂದರೆ ಈ ಥರ ಮೈಕ್ರೋ ಮಿನಿ ಸ್ಯಾಟಿಲೈಟ್ಸ್ನ ಲಾಂಚ್ ಮಾಡೋದಕ್ಕೆ ದೇ ಆರ್ ಜಸ್ಟ್ ಬಿಲ್ಡಿಂಗ್ ದಟ್ ಟೆಕ್ನಾಲಜಿ. ದೇ ಆರ್ ಲೈಕ್ ಬಿಲ್ಡಿಂಗ್ ದಟ್ ಲಾಂಚ್ ವೆಹಿಕಲ್ ಸ್ಟಿಲ್, ಬಟ್ ಒನ್ಸ್ ದಟ್ ಈಸ್ ರೆಡಿ, ಇವನ್ ಇಂಡಿಯಾ ಕ್ಯಾನ್ ಲಾಂಚ್ ದಿಸ್ ಮೈಕ್ರೋ ಮಿನಿ ಸ್ಯಾಟಿಲೈಟ್ಸ್. Okay, and then we have other next gen launch vehicle also they are doing. ಏನಂದ್ರೆ reusable ಇದೆಲ್ಲ reuse ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ. all of this ಇವಾಗ ಕೆಳಗಡೆ ಬೀಳತ್ತಲ್ಲ ಇದೆಲ್ಲ, so we cannot reuse this which is used for the fuel. but next gen ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ we can reuse the parts around for like 15 to 20 times ಅಂತ. So that we do not have to spend so much money on building just one rocket. We can reuse the parts and then namge cost kadme agate anta. They are also planning to do this reusable launch vehicles, and that is in the future. So right now we have only till GSLV Mark 3 or LVM Mark 3. Okay. So you can write about this first SLV satellite launch vehicle. ಇಲ್ಲಿ ಏನಿಲ್ಲ, ಫಸ್ಟ್ SLV ಅಲ್ಲಿ all 4 stages were solid fuel. All 4 stages solid, and payload 40 kgs to low earth orbit, LEO, low earth orbit. Then ASLV, augmented satellite launch vehicle. ASLV bandi augmented satellite launch vehicle. So this one had 5 stages, all solid fuel. And 150 kg was the payload. 150 kgs. Low earth orbit only. So next PSLV, that is Polar Satellite Launch Vehicle. So here it had 4 stages, 2 solid and 2 liquid stages. 2 solid and 2 liquid stages. Payload was 3,250 for low earth orbit and 1,600 for sun synchronous, 1,600. 1,400 was for geostationary orbit. $1,600 for the polar orbit. Okay, 1,400 for geostationary orbit. So here PSLV example was Chandrayaan 1 and Mangalyaan. Then we have GSLV, Geosynchronous Satellite Launch Vehicle. GSLV, Geosynchronous Satellite Launch Vehicle. This was for this has three stages. First liquid, one liquid stage, and then one solid, liquid and cryogenic. And this can payload for this is geostationary orbit. For geostationary orbit it is 2200 kilometers, and for low earth orbit it is around 6000 kgs. 6000 kg for low earth orbit, 2200 for geostationary. Then we have GSLV Mark III. So, GSLV Mark III or LVM Mark III, Launch Vehicle Mark III antanu karitare. So, this is also 3 stage again, solid, liquid and cryogenic fuel. So, this has a payload capacity of 4000 kilometer, 4000 for geostationary and 10,000 for low earth orbit. Chandrayaan 3 was this GSLV Mark III. Next you can just write about the small satellite launch vehicle, SSLV, small satellite launch vehicle, which can launch mini, micro or nano satellites. So, it will be around 10 to 500 kgs payload, mini, micro or nano satellites, 10 to 500 kg of payload and up to 500 kilometer in low earth orbit. What about the payload capacity? 10 to 500 kgs. Next you can write next gen launch vehicle. Next gen launch vehicle. This is a 3 stage, partially reusable, heavy lift, launch vehicle. It will have a reusable first stage. Which can be utilized 15 to 20 times. So, it has a maximum payload of 30,000 kgs. 30,000 kgs for low earth. Yeah. For it will gradually decrease as we go to higher up. For geostationary, it will reduce. We have not mentioned, like, let me just. Around 10,000 kgs for geostationary. 10,000 kgs for geostationary. Yeah, it is greater, obvious. It is 10,000 kgs for geostationary. Like? Geostationary will be 36,000 kilometer only. That will not change. So, for geostationary orbit, the height, the altitude will be always 36,000 kilometer only. So, then only the satellite can be in orbit around the earth, otherwise it will, it cannot stay in an orbit. So, next we have this launch sites, rocket launching sites in India. So, right now we are using this Satish Dhawan Space Center, Sriharikota, that is there in Andhra Pradesh, off coast of Andhra Pradesh. So, there only there is two launch pads. Two launch pads are present in Sriharikota, and they are building third launch pad. ಅಂದರೆ ಈ ನೆಕ್ಸ್ಟ್ ಜೆನ್ ಲಾಂಚ್ ವೆಹಿಕಲ್ನ ಲಾಂಚ್ ಮಾಡೋದಕ್ಕೆ ವಿ ನೀಡ್ ಅ ನ್ಯೂ ಲಾಂಚ್ ಪ್ಯಾಡ್. ಸೊ ಅದನ್ನ ಇವಾಗ ಬಿಲ್ಡ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ರೆಡಿ ಬೈ ಅರೌಂಡ್ 2030. Okay, so there is 3 launch pads. There is going to be 3 launch pads. And there is another one that is they have built in this Tamil Nadu, Kulasekharapattinam space port. So that will help in launching this mini satellites, mini, micro, nano satellites, SSLV. ಅದನ್ನ ಲಾಂಚ್ ಮಾಡೋದಕ್ಕೆ ದೇ ವಿಲ್ ಯೂಸ್ ದಟ್ ಸ್ಪೇಸ್ ಪೋರ್ಟ್, ಕುಲಶೇಖರಪಟ್ಟಿನಂ ಸ್ಪೇಸ್ ಪೋರ್ಟ್ ಇನ್ ತಮಿಳ್ನಾಡು. And then there is one more, this Abdul Kalam Island. It is mainly used for defense purposes, okay, to test this missile launch and all of that. Abdul Kalam Island, that is there in Odisha. It is used by DRDO to test these missiles. And then Vikram Sarabhai Space Center, that is there in Kerala, they help in the development of the satellites, that center. These particular locations. So why they are using this particular location is, one, it is closer to the equator. Okay, one, it is closer to the equator, so it will have an initial push off to take to the orbit. And suppose the satellite fails, it can come and fall into the ocean. So it will not come and fall into the land where it can destruct. So it can fall into either Indian Ocean or the Bay of Bengal region. So that is why they are choosing only in the eastern coast. Okay, so these are the two reasons. So you can write that point also, why they are using the consideration for selecting rocket launch pads. First point under that, ಬರೀ ನೇಮ್ಸ್ ಬರ್ಕೊಳ್ಳಿ ಸಾಕು, ನಥಿಂಗ್ ಎಲ್ಸ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. So first point under the consideration, Shall I tell? Okay. Proximity to the equator. Proximity to the equator. It provides initial boost. It provides an initial boost and helps in cutting down the fuel requirement, to reach the orbit. And then location on the eastern coast. In case of failure, the debris can fall in Bay of Bengal. Location on the eastern coast. So, all of this launching sites is in the eastern coast, right. So, in case of any failure, the debris can fall into Bay of Bengal and Indian Ocean. And even this NASA's Space Center, Kennedy Space Center. So, that is there in Florida. Florida is located in the eastern coast and it is closer to the equator. Okay. So, next we will see the important space missions of ISRO. So, the recent ones only I have taken up, not very old ones. So, we will see only the recent ones. So, the first one is Aditya L1. So, Aditya L1 mission was launched in the year 2023. Okay. So, it is, this one is used to measure, observe the sun's surface, especially the corona, photosphere and the chromosphere of the sun. So, they launched this to study the upper layer of the sun, study about the solar winds and all of that. Nene discuss madwala, solar winds, coronal mass ejections. So, idir bagge study madadike they launched this Aditya L1. And why it is named as L1? So, L1 is nothing but a Lagrange point. Okay, it is a Lagrange point. So, ee Lagrange points enandre, so when there is two objects in the universe, so it is attracted by the gravitational force. It is given by this universal gravitational law that the gravitational force is given by the universal gravitational law. So, now there is earth here and sun, right. There are 5 Lagrange points. See, Lagrange points alli enagutte andre, the gravitational pull. So, even earth will exert some gravitational pull towards the sun and sun will also exert some gravitational force towards the earth. So, at these points a gravitational force enide that will cancel out and help any object to remain stationary. So, usually enagutte the objects will start revolving around any like for suppose earth or the sun, right. But at these points it will help any object to stay stationary. Okay. So, slight movement irutte, but it will not go into an orbit. Alli stationary agirutte, yake andre the gravitational force will cancel out at these points. So, L1 bandi, it is in between the sun and the earth and it will give an uninterrupted view of the sun. Okay. So, that is why they chose this L1, Lagrange point L1, and Lagrange point L2, it is behind the earth. This James Webb Space Telescope, I told you, James Webb Space Telescope NASA launch madirodu. So, adu bandi L2 alide. Okay. These 2 points are relatively closer to the earth, it is easier to launch, and L3 is beyond sun, that will be very difficult to, you know, place an satellite there, and L4 and L5 also, it is very far from the earth. So that's why we are making use of this L1 and L2 as of now, but in future they might send to L4 and L5 also. Okay. So this is about the Lagrange points. So first you can write Aditya L1 mission. So under that, India's first solar mission to study, India's first solar mission to study upper layer of the sun, and it was launched in 2023. And yeah, next you can write Lagrange points. Lagrange points are positions in a moving two body system where the combined gravitational force of two large bodies acting on a third body of smaller mass, cancel each other out. So L1 point, there are 5 points, L1, L2, L3, L4 and L5. So L1 is roughly 1.5 million kilometers. 1.5 million kilometers, and it provides uninterrupted view of the sun. Okay. Next we have this Gaganyaan mission. So Gaganyaan mission is the mission to send humans to this space, to the low Earth orbit. So they will be traveling to the low Earth orbit for 3 days, and they will be in the orbit for 3 days and they are going to come back. So this will help us in building this Indian space station. We need to place that Indian space station in a low Earth orbit. This will help, this will be like a test flight of sending humans. So if India sends humans successfully, then India will be the 4th country to send humans to space. So Russia, China and USA has so far sent humans to space. So India will be the 4th country to send human to space independently. And they are planning to do this. It was supposed to happen this year, but they have pushed it, it will happen in 2026. But they did a test flight, they used this robot for that, Vyomitra, okay, which came back successfully, but they are taking more time to send humans. 3 people they have selected, 3 astronauts like from this Indian Air Force and all of that. Subhanshu Sharma something, his name is Shukla, Subhanshu Shukla, he'll be the captain and other 2 will be there, astronauts. Huh? Yeah, he went with NASA, yeah, the same person. So he went to, recently he went like some 3-4 months back in NASA spacecraft. So he'll be traveling in this Gaganyaan mission also. So you can write about Gaganyaan mission. It is ISRO's human space flight. ISRO's human space flight, which will carry 3 astronauts. To low Earth orbit for 3 days mission. To low Earth orbit for 3 days mission and bring them back. At least 7 days. Okay, in this they have given 7 days. Yeah, it is 3 days, I think. It is 3 days only. 1 second. Yeah, it is a human spaceflight mission which will carry 3 astronauts to low Earth orbit for a 3-day mission and bring them back. It is 3 days only. Crossed. And it is planned for 2026. It is planned for 2026. They will use this LMV-3 only, Launch Vehicle Mark III for Gaganyaan mission. Three only, plus that robot will be there, I think. Yes, it is 3 astronauts only. Let me check once. Yeah, it is four persons, sorry. So next we will see the Chandrayaan missions. So Chandrayaan 1, it was launched in the year 2008. So what did Chandrayaan do is it just went to the lunar orbit. It orbited around the moon for a few days and it sent out images from the moon to the earth, images of moon, and this confirmed, Chandrayaan 1 confirmed that this water ice presence in the moon. So you know there is a possibility of water to be present on the moon's surface, and this was confirmed by the photo sent by the Chandrayaan 1. Okay. So under Chandrayaan 1 you can write India's first moon mission. India's first moon mission launched in 2008. Launched in 2008 and the spacecraft orbited around the moon at a height of 100 kilometers, at a height of 100 kilometers. It gave a proof of presence of water ice. Then Chandrayaan 2. So this was launched in the year 2019. So this had a 3 module here, like orbiter, lander and a rover. So first initially it will orbit around the moon for few days, and then it will softly land on the moon. So using a lander, and then the rover, it will come out of this lander and it will explore the moon's surface and it was supposed to send data from there to the earth. But while landing only, it crashed due to some error in 2019, and this was not successful, this mission. So later they launched the Chandrayaan 3. So Chandrayaan 3 was launched in the year 2023, right, August 23rd, launch on Friday, sorry, July 14th. So it touched the moon on August 23rd. So it was launched on July 14 and touched the moon around August 23rd. So even this had a lander, and the lander was named as Vikram lander and Pragyan rover. So even this collected some data on the moon's surface, and that information was sent back to the earth. Okay. And India was the 4th country to again soft land on the moon, and this was sent to the southern pole of the moon. So that is a darker side. So moon is actually, we can see always only one side of the moon. Other side we cannot see because it is tidally locked. We call it as tidally locked because the rotation and the revolution of the moon, rotation of the earth and the revolution of the moon is same, around 28 days. So that is why we can see only one face of the moon. That is what we call it as tidally locked. So moon is tidally locked to the earth. So this south pole is at the farther side of the moon, where nobody has explored so far, and India was the first to go to this south pole. And later even China has sent some of its Luna mission, not Luna, Chang'e mission to the south pole also. Later it launched. Chang'e 4 was launched by China, and it went to the south pole as well. And then they are planning to send one more mission to moon, that is Chandrayaan 4. So what this will do is, it is going to come back to the earth. It is going to land, collect the samples from there and take it and come back to the earth, Chandrayaan 4, and it will be in the future. Around 2027 or 28 they are planning to do this one, Chandrayaan 4 mission. Okay. So you can write about Chandrayaan 2, launched in 2019. It consisted of orbiter, lander and a rover. Orbiter, lander and a rover. The Vikram lander crashed while soft landing on the moon, due to a software error. Vikram lander crashed while soft landing on the moon due to a software error. Then Chandrayaan 3 launched in 2023. Spacecraft consisted of Vikram lander, and Pragyan rover. Vikram lander and Pragyan rover. The landing site was closer to the south pole of the moon. The landing site was closer to the south pole of the moon. The rover collected lunar samples. The rover collected lunar samples and sent data to the earth. So, India became the fourth country to land on moon after USA, Russia and China. So, that place where this Chandrayaan 3 landed, so they have named it as Station Shiv Shakti. So, there is this astronomical union which gives names for these places like that. So, they have named where Chandrayaan 3 was landed, no. So, that is called as Station Shiv Shakti. Next, Chandrayaan 4 expected to launch around 2027. It is aimed to collect samples. It is aimed to collect samples from the moon's surface, to the earth and bring them back to the earth. So, next we have this Shukrayaan mission. So, this will be the second interplanetary mission by ISRO after Mangalyaan. So, this is expected to be launched by 2028 Shukrayaan. So, this is going to study about the Venus atmosphere and how the solar winds interfere with the Venus atmosphere and all of that. Similar to this Mangalyaan mission. Okay. So, you can write this Shukrayaan mission. It is expected to be launched by 2028. It is India's second interplanetary mission. After the Mangalyaan. It is aimed to study the structure, composition and dynamics of Venus atmosphere. So, next we have XPoSat, X-ray polarimeter satellite. So, this is India's first X-ray polarimeter satellite. So, it was launched in 2024. And what is the aim of the satellite. It is to study the X-rays. You know, this X-rays are, you know, emitted from this neutron stars. We saw, no, I told you that neutron star will spin at a very high speed and it is going to emit this X-rays. And also pulsars. Pulsars is also another object, you know, which will be revolving very fast. So neutron star eventually will end up as a pulsar. Okay. So this pulsar will, you know, emit this faint X-rays and we have to detect from the, it will help us to detect from where this X-ray is coming from. And also black holes, to study neutron stars, pulsars and black holes. Now why it is called as polarimeter? Because, you know, there is this polarization happening here. You know, the light coming, the light is traveling in the form of electromagnetic spectrum and X-ray is part of this electromagnetic spectrum. So this light, you know, it will have a glare, like, you know, if we see the sun, you know, when we wear this sunglasses, avaga glare kadme agatala, that is why we wear the sunglasses. Because, you know, the light will be vibrated in all directions if it is unpolarized. Initially when the light is coming, it will be unpolarized and it will scatter in all the direction. ಮತ್ತೆ ಅದು ಸ್ಯಾಟಲೈಟ್ ಬಂದು ಹೊಡೆದಾಗ ಇಟ್ ವಿಲ್ ಒಂಥರ ಗ್ಲೇರ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಗ್ಲೇರ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ದೇರ್ ಇಸ್ ದಿಸ್ ಪೋಲರಿಮೀಟರ್ ವಿಚ್ ವಿಲ್ ಪೋಲರೈಸ್ ದ ಲೈಟ್, ವಿಚ್ ವಿಲ್ ಪೋಲರೈಸ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಸ್ಪೆಕ್ಟ್ರಮ್. ಸೊ ಆ ಗ್ಲೇರ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ದ light we can study it even more better when it is polarized. So unpolarized light is that it will vibrate in all directions, and this, when polarization is happened, when this polarimeter helps in polarization of light, then it will reduce those vibration and it will not let the light to scatter in all directions. Okay. So that is why it is called as X-ray polarimeter satellite, XPOSat. So you can write about XPOSat. It is India's first satellite to study X-rays from sources like neutron stars, black holes and pulsars. And it is placed in the low Earth orbit. It is placed in the low Earth orbit. The polarimeter helps in polarization of light, that is restricting the vibration of light waves to one specific direction, that is restricting the vibration of light rays to one specific direction. So next we have this NISAR satellite. So this is a joint mission of ISRO and NASA, and it is a remote sensing satellite. So which is going to study the Earth's surface basically. So it's going to study the Earth's surface, you know, in learning about this climate change and how the weather patterns are changing, and also, you know, geomorphology, this movement of ice glaciers, because the ice glaciers are moving very fast due to the climate change happening. So, it is going to study about all of that. It is also placed in the low earth orbit only, in the it is in the polar orbit, that is low earth only again. Okay. So, you can write about NISAR, NASA ISRO joint satellite. It is a remote sensing satellite. It was launched in 2025. It was launched in 2025 and it is placed in the low earth orbit. Placed in the low earth orbit. It is going to study about movement of glaciers and ice sheets, geomorphology, movement of glaciers and ice sheets, geomorphology, ice sheets, geomorphology and vulnerability of wetlands, thereby monitoring climate change. Next we have this SpaceDex machine. So, SpaceDex machine was an experimental machine to test the docking system, space docking system. So, two satellites were brought closer to each other and it docked. Dock andre ontara lock agatara, similar to locking. If you actually watch this Interstellar movie, if you have not watched it, you actually go and watch it. It is very interesting. Maybe the first time you watch, you will not understand anything because it is they have used some complex astronomical things, because they have told about time dilation also in that movie. What is this time dilation is? When you go near this massive objects in the universe. So, the massive object known to us is right now is the black hole. Black hole is very massive, it is very dense. So, black hole hatra hodaga time will run slower for us relatively. So, time on earth will go faster and somebody who is there near the black hole, for them the time will go slowly. So, because of the strong gravitational force, they have shown about this time dilation and they have shown about the wormhole. So, wormhole is connecting 2 points in space. So, wormhole it is, there are these 2 points here and if it is bent like this, creating a hole, and these 2 points can be travelled very easily and it will be a very shorter distance. They have shown about the wormhole and this docking also, docking system is shown. They will travel in this spacecraft to some other galaxy and from there they had to go to land on some planet to see whether that is suitable for, they would have already sent some missions. Already on ಸ್ವಲ್ಪ ಜನ ಕಳಿಸಿರ್ತಾರೆ. Then these people will go to check whether those planets are habitable for humans. So, they will go, they have to go from there, they will undock themselves from the spacecraft. The spacecraft will be revolving around the planet. A spacecraft in the undock ಮಾಡಿ, they will go land on that other planet and they will see what is the condition there, and then they will come back up again and they will dock into the spacecraft again. So, then actually they will go to another planet and they will, and the the person was acting like he'll go into the black hole. So that shows, you know, our imagination, the Christopher Nolan's imagination of how black hole is actually. We don't know whether the black hole is actually like that, it is just imagination by, you know, the studies, all of the studies. And he extensively worked with NASA and all of it for, you know, doing this movie. It is a really nice movie. And there was another movie also, I don't remember the name of it. Gravity, yes, yeah, Gravity. Even that is also good. You can understand about the space mission. See, docking align ಮಾಡ್ತಾರೆ ಅಂತ. It's really nice. Please go watch if you have not watched it. ನೀವು ನೋಡಿದ್ದೀರಾ? Have you? Okay. So I watched it 2 times to, you know, actually fully understand the movie. I watched it when I was in my masters. So, and my brother had to explain me little what is happening in the movie. Then only I understood. So it is really nice. So this SpaceX is also, you know, the docking, because India is launching this India's own space station in the future. So we have to go dock and, you know, to send people to the international, I mean sorry, not international space station, India's space station. So this docking should be known to Indians. So this is a test, and they did this test this year only, in August or something they completed this docking. So it successfully docked, and later they gave commands and it undocked also. So this was the SpaceX mission by ISRO. So you can write about the SpaceX mission. It was launched in 2024 to demonstrate satellite docking in space, to demonstrate satellite docking in space. The two satellites were brought within within a distance of 3 meters, from each other, in orbit. Their extended ring was joined with each other. Their extended ring was joined with each other and locked in space. Later the satellites were undocked successfully. So this will you know, pave way for this Bharatiya Antariksha Station. So again, India is again the 4th country to do this after China, Russia and USA. So China has its own space station, Tiangong Space Station, right? And this International Space Station, it is a collaboration of this European Space Agency, NASA and JAXA, and all of the space agencies collaborated and built the International Space Station. Okay. Next we have this analog mission. So analog mission, it's nothing but in Ladakh region, okay, where the conditions are very, very extreme. There is some valley called Somore Valley. So there, the oxygen levels is very low, and the conditions resemble similar to the Mars's atmosphere. So, they have built this Hope cubicle, Hope cubicle in the Ladakh region in Somore Valley. So that will provide this people, to actually experiment there and adapt to that condition, so that it is similar to the Mars surface. So once, next stage of Mangalyaan will be like, to land people on the Mars and to, carry out some experiments over there. So that is why they have planned this mission to adapt to the conditions here first and to experiments and all of that. This is like a test before going to the Mangalyaan, before going to the Mars. So that is analog mission, and it is present in the Ladakh Somore Valley. So you can write ISRO launched its first analog or simulated space mission, at Somore Valley in Ladakh. The mission includes a compact inflatable habitat named Hope, H-O-P-E, Hope, designed to mimic environments on Mars. So they are going to test all these technologies and robotic equipment, everything here. So technologies, robotic equipment, communication will be tested. So, there is this space debris. So, all of the satellites that we have launched, it will stay in that orbit only. Andre ivaga ondsati adu functional agi dysfunctional adre, it will still remain in the orbit. It will be orbiting around the earth, even though if it is not functioning, even though it is not sending out any data or any signal, it will still be there in the orbit only, revolving around the earth. So those parts are called as space debris, the leftover materials over there. So this leftover materials, it has a possibility. So debris, that is traveling, if it touches this functional satellite, then even that can break, and further it will continue like a chain. It can go and hit another satellite. So it will continue like a chain, destroying other functional satellites also. So that is the problem of this space debris, and that we call it as Kessler's syndrome. Where this small debris can go hit this functional satellites and destroy that as well, and it will be in like a chain reaction. How we saw in this fission reaction is like a chain reaction alla. So one fast neutron bandi hit adre, then it will be decaying, right. So similar like that, it will go on in a chain, destructing other satellites also. So that we call it as Kessler syndrome. To detect this space debris. So, India has this project called as Project Netra. So, Netra is like a warning system to detect this space debris so that it will not hit any functional satellites in the space. Okay. So, that is this Project Netra. So, you can write about what is space debris, Kessler syndrome and Project Netra. So, first space debris. Human made objects in space, human made objects in space that are no longer in use, that are no longer in use, such as discarded rocket stages, discarded rocket stages, defunctional satellites, and these debris can remain in orbit, satellites, etc. And these debris can remain in orbit, for years. Next, Kessler syndrome. Kessler syndrome. Phenomenon in which the density of the objects in the low Earth orbit grows so high, density of the objects in the low Earth orbit grows so high that collisions in the low Earth orbit grows so high that collisions between two objects could cause a massive cascade of space junk, and trigger further collisions, Two objects could cause a massive cascade of space junk and trigger further collisions. So, Project Netra, initiative by ISRO, an early warning system in space to detect debris and hazards, to Indian satellites, That's all. So, you can take a break and come back by 12:05, 12:10. So, next we will go on with how this GPS works. So, GPS andre global positioning system. So, ಅಂದ್ರೆ exact location, ಅರ್ಥಲ್ಲಿ exact location ಗೊತ್ತಾಗಕ್ಕೆ we use this GPS. So, GPS is actually, you know, it's a bunch of satellites that will help us in locating any target. Okay, na? So, it is GPS is actually launched by USA. And we have our own regional navigation that is we call it as NAVIC anta. Okay, we will see about NAVIC also. First, how can we know the location of, you know, somebody like ivaga you know, especially this police and all of them, they track, right? So track ಮಾಡಿ ಲೊಕೇಶನ್ ಫೈಂಡ್ ಮಾಡ್ತಾರೆ, ಮೂವೀಸ್ ಎಲ್ಲ ನೋಡಿರ್ತೀರ, they keep tracking GPS location track ಮಾಡ್ತಾರೆ and all of that. So how do they track the location? How will they know the location? So ಇಲ್ಲಿ ಫಸ್ಟ್ ಏನಂದರೆ, ಇವಾಗ ನಮ್ಮ ಮೊಬೈಲ್ ಫೋನ್ಸ್ ಇಂದಾನೆ they will basically track. ಸೊ ನಮ್ಮ ಮೊಬೈಲ್ ಫೋನಲ್ಲಿ ದೇರ್ ವಿಲ್ ಬಿ ದಿಸ್ ರಿಸೀವರ್. ಓಕೆ, ರಿಸೀವರ್ ಇರುತ್ತೆ. ಸೊ ಆ್ಯಕ್ಚುಲಿ ನಾವು ಲೊಕೇಶನ್ ಟ್ರ್ಯಾಕ್ ಮಾಡಬೇಕಂದ್ರೆ ಫಸ್ಟು ಮೊಬೈಲ್ ಆನ್ ಆಗಿದ್ರೇ ಯುನೋ ಟ್ರ್ಯಾಕ್ ಮಾಡೋಕ್ಕಾಗೋದು. ಇಫ್ ಇಟ್ ಇಸ್ ಸ್ವಿಚ್ಡ್ ಆಫ್ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ಟ್ರ್ಯಾಕ್ ಇಟ್. ಸೊ ಆನ್ ಆಗಿರಬೇಕು, ದೆನ್ ದೇರ್ ಇಸ್ ಎ GPS ರಿಸೀವರ್ ಇನ್ ಅವರ್ ಮೊಬೈಲ್ ಫೋನ್ಸ್. ಸೊ ಏನಾಗುತ್ತೆ, ದೇರ್ ಆರ್ ಬಂಚ್ ಆಫ್ ದಿಸ್ ಸ್ಯಾಟಿಲೈಟ್ಸ್, ಮಿನಿಮಮ್ ಲೈಕ್ 3 to 4 ಸ್ಯಾಟಿಲೈಟ್ಸ್ ಬೇಕು ಟು ನೋ ದ ಎಕ್ಸಾಕ್ಟ್ ಲೊಕೇಶನ್. 3D ಲೊಕೇಶನ್ ಬೇಕು ಅಂದರೆ ನಮಗೆ ಮಿನಿಮಮ್ ಆಫ್ 3 or 4 ಸ್ಯಾಟಲೈಟ್ಸ್ ಬೇಕು, ಬಿಕಾಸ್ ದಟ್ ಈಸ್ ಅ ಟ್ರೈಲ್ಯಾಟ್ರೇಷನ್ ಮೆಥಡ್ ವಿ ಯೂಸ್. ಲೈಕ್ ಇದರಲ್ಲಿ ಬೇಸಿಕ್ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಕೋಆರ್ಡಿನೇಟ್ ಜಾಮೆಟ್ರಿನ ಅಪ್ಲೈ ಮಾಡ್ತಾರೆ ಇಲ್ಲಿ, ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಆಸ್ ಕೋಆರ್ಡಿನೇಟ್ ಜಾಮೆಟ್ರಿ. ಸೊ ಈ ಸ್ಯಾಟಲೈಟ್ಸ್ ಏನು ಮಾಡುತ್ತೆ, ಇಟ್ ವಿಲ್ ಸೆಂಡ್ ಎ ಸಿಗ್ನಲ್ ಟು ದ GPS ರಿಸೀವರ್. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ನಿಯರ್ಲಿ ಟು ದ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್, ನಾಟ್ to exactly the speed of light, but closer to the speed of light. So ಈ ರೇಡಿಯೋ ಸಿಗ್ನಲ್ಸ್ನ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಮಾಡುತ್ತೆ ಸ್ಯಾಟಿಲೈಟ್ಸ್. ಸೊ ಸ್ಯಾಟಿಲೈಟ್ಸ್ ಲೊಕೇಶನ್ ಗೊತ್ತಿರುತ್ತೆ, ಸ್ಯಾಟಿಲೈಟ್ ಲೊಕೇಶನ್ ಅಂದರೆ ಡೇಟಾನು ಕಳಿಸುತ್ತೆ. ಆ್ಯಂಡ್ ಇಟ್ ಆಲ್ಸೋ ಸೆಂಡ್ ದ ಟೈಮ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ದ ಸಿಗ್ನಲ್ ಟು ಟ್ರಾವೆಲ್ ಫ್ರಮ್ ದ ಸ್ಯಾಟಿಲೈಟ್ ಟು ದ GPS ರಿಸೀವರ್. ಎಷ್ಟು ಟೈಮ್ ತೊಗೊಳತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುತ್ತೆ, ಮತ್ತು ಸ್ಪೀಡನ್ನು ಆಲ್ರೆಡಿ ಗೊತ್ತಾಗಿರುತ್ತೆ. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್, ಯು ನೋ, ಇಟ್ ವಿಲ್ ಆ್ಯಕ್ಚುಲಿ ಲೊಕೇಟ್ ದ ಟಾರ್ಗೆಟ್ based on the speed of the signal sent and the time taken by the signal. So by the GPS receiver. So based on that, ಈ 3 satellites location ಗೊತ್ತಿರತ್ತಲ್ಲ, ನಾವು ಆ ಟೈಮು ಮತ್ತು ಏನು ಸ್ಪೀಡ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ವಿ ಕ್ಯಾನ್ ನೋ ದ ಟಾರ್ಗೆಟ್ಸ್ ಲೊಕೇಶನ್. ಸೊ ಅದಕ್ಕೆ ನಮಗೆ 3 ಸ್ಯಾಟಿಲೈಟ್ಸ್ ಬೇಕು ಎಕ್ಸಾಕ್ಟ್ ಪಾಯಿಂಟ್ನ. ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ನೋಡಿ X1, X2 X1, Y1, Z1. ಸೊ ದಟ್ ಈಸ್ ನಾವು ಇವಾಗ ಕೋಆರ್ಡಿನೇಟ್ ಜಾಮೆಟ್ರಿಯಲ್ಲಿ ನಾವು ಈ ಗ್ರಾಫ್ ಎಲ್ಲ ಪ್ಲಾಟ್ ಮಾಡ್ತಾ ಇದ್ವಲ್ಲ, ಸೊ ನಾವಲ್ಲಿ ಬರೀ X ಮತ್ತು Y ಕೋಆರ್ಡಿನೇಟ್ ತೊಗೋತಾ ಇದ್ವಿ ಟು ಪ್ಲಾಟ್ ಸಮಥಿಂಗ್ ಆನ್ ದ ಗ್ರಾಫ್. ಬಟ್ ಇಲ್ಲಿ ನಾವು ಝೆಡ್ ಏನಕ್ಕೆ ತೊಗೊತೀವಿ ಅಂದರೆ, ಇವಾಗ ಪೇಪರ್ ಮೇಲೆ ಪ್ಲಾಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದು 2D ಡೈಮೆನ್ಷನ್. ಸೊ ಇಲ್ಲಿ ನಮಗೆ 3D ಡೈಮೆನ್ಷನ್ ಬೇಕು. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇನ್ನೊಂದು ಕೋಆರ್ಡಿನೇಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀವಿ. ಸೊ 3 ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಇದ್ದರೆ ಅದು 3D ಆಗುತ್ತೆ. ಸೊ 3D ಲೊಕೇಶನ್ ಇರುತ್ತೆ. ಮತ್ತು T is nothing but the time taken by the satellite to send that signal, reach that signal. Sorry. So based on the trilateration method, we will note the exact location of the target. ಸೊ ಆ GPS ರಿಸೀವರ್ ಫಸ್ಟು ಆನ್ ಆಗಿರಬೇಕು, ಆವಾಗ ಆ ಸ್ಯಾಟಲೈಟಿಂದ ಸಿಗ್ನಲ್ ಕಾಣಿಸುತ್ತೆ. ಬೇಸ್ಡ್ ಆನ್ ದ ಸ್ಪೀಡ್ ಆ್ಯಂಡ್ ದ ಟೈಮ್ ಟೇಕನ್ ವಿ ಕ್ಯಾನ್ ಆ್ಯಕ್ಚುಲಿ ಗೆಟ್ ದ ಲೊಕೇಶನ್ ಆಫ್ ದ, ಅದು ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಕೊಡುತ್ತೆ ನಮಗೆ. ಯೂಶಲಿ ಇಟ್ ವಿಲ್ ಗಿವ್ ದ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ವೇರ್ ದ ಟಾರ್ಗೆಟ್ ಇಸ್ ಅಂತ. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ದ ಲೊಕೇಶನ್ ಆಫ್ ಎನಿಥಿಂಗ್ ಆನ್ ದಿ ಅರ್ತ್. ಸೊ ದಟ್ ಈಸ್ ವೈ ವಿ ಯೂಸ್ ದಿಸ್ ಗ್ಲೋಬಲ್ ಪೊಸಿಷನಿಂಗ್ ಸಿಸ್ಟಮ್. ಓಕೆ, so you can write about this GPS, working of GPS. So GPS receiver picks signal from multiple GPS satellites. GPS receiver picks up signals from multiple GPS satellites. Each satellite send next point, each satellite send radio signals nearly to the speed of light, nearly to the speed of light, that includes information about the satellite's location and precise time the signal was transmitted, and the precise time the signal was transmitted. GPS receiver measures the time it takes for the signals to reach and can calculate the distance between itself and each satellite, With the distance measurement, the receiver can determine an object's precise 3D position. The receiver can determine an object's precise 3D position. So 3D position ಏನು ಕೊಡುತ್ತೆ ಅಂದರೆ it will be latitude, longitude and altitude. ಸೊ ಅವಾಗ the 3D coordinate ಕೊಡಂಗೆ. So ಇಲ್ಲಿ actually we will not know the exact to the point ಅಂತ. We can locate the ಒಂದು 10 or 20 meters radius ಅಲ್ಲಿ ಇದೆ ಈ ಲೊಕೇಶನ್, ಈ ಟಾರ್ಗೆಟ್ ಇಲ್ಲಿದೆ ಅಂತ ನಾವು ಪ್ರಿಸೈಸ್ ಆಗಿ we can not exact location kodake, because some error will always be there. Okay. So next we have, so where can this GPS be used? One is tracking. Of course, tracking. Navigation use ಮಾಡಬಹುದು. We can use it for navigation. And mapping also. Surveys and mapping. We can use GPS for surveys and mapping. And other military operations and all of that, we can use GPS. Okay. So next we have this NAVIC. So navigation with Indian constellation, that full form only, navigation with India's constellation. So it was before called as IRNSS, Indian Regional Navigation Satellite System anta, adna rename madidru NAVIC anta, from IRNSS to NAVIC. So illi 7 satellites ide. So this will cover only this Indian region. So illi region kottidaralla. So these satellites can cover only, can track the location of targets in this area only, because there are only 7 satellites. Idalli 3 satellites na geostationary orbit alli ittidare, and 4 satellites in the geosynchronous orbit. So it has total 7, 3 bandi geostationary allide and 7 in geosynchronous, and it will give a regional coverage of this much area. But whereas GPS, which is actually sent by the USA, it covers entire Earth. And we have Russia's also, GLONASS anta, even that will cover entire Earth. Indiadu matte Japan matra, it is a regional coverage. Okay. So you can write NAVIC is satellite navigation. NAVIC is satellite navigation system developed by ISRO. Developed by ISRO. Consists of 7 satellites. Consists of 7 satellites. 3 in geostationary and 4 in geosynchronous. 3 in geostationary and 4 in geosynchronous. It extends up to 1500 kilometer, 1500 kilometer around the country. And it provides position accuracy. It provides position accuracy of more than, sorry, of better than 20 meters. Of better than 20 meters. So this is about NAVIC. So these are the different satellite based navigation. So GPS bandi United States though, then GLONASS Russia, and then BDS, some I don't know how to spell that, navigation satellite system of China, and then IRNSS now renamed as NAVIC by India, and Galileo, it is European Union's, that is also global coverage it has, and Zenith, quasi Zenith satellite system by Japan. So even that is regional. So only 2 regional, India matte Japan matte regional, rest all have this global coverage. And they provide it for civilian purposes also, but only Russia's is for military purpose. They use entirely for military purpose. Okay. You can write bari navigation system country's name and whether it is global or regional. This is, these two, operator and type is not required, you just write that.
Why do we still follow GPS even though we have our own country's navigation?
Because it has better accuracy. GPS has better accuracy than this NAVIC. Okay. This NAVIC, mostly it is used by this military, Indian military and all of it, because there has to be some secrecy in that. So mostly, but they give it for civilian purposes also. Done? Okay. Right. So next we have this satellite. Did you? Okay. Right. Yes. So next we have this satellite internet. So this is in the future, like how the satellite internet system is going to work. So it is basically a wireless internet from which is beaming down from the satellites. Ivaga ನಾವು communication ಗೆ ಹೆಂಗೆ radio signals use ಮಾಡ್ತೀವಿ. So similarly in that way there's going to be huge antennas which is going to take the signals from the satellite and then transmit it to the mobile phones and provide internet here. So this is going to be wireless. So far we have been using the optical fibers, optical cables to transmit the internet, and then there will be this routers which will provide internet to specified area, specified location, right. So dura hodre we cannot use that internet, right. So but this will provide a wide coverage and matte remote areas ge we can give this internet anta. So that is what the main aim of this satellite internet. But what is the drawback andre, this should have a clear line of sight, because if there is something coming in between, then it cannot transmit that internet, wireless internet or data signals. So that is one drawback. And latency andre the time taken by the signals to travel. So namge ee optical cables alli latency tumba kadime irutte, latency will be very low, so that our internet speed is very fast. But here it will take some time for the signal, because it has to come from the satellite to the ground. So there will be some latency. Andre ivaga ನೀವು ವೆಬ್ ಪೇಜ್ ಏನಾದರೂ ಓಪನ್ ಮಾಡ್ತೀರಾ ಅಂದರೆ ಲೋಡ್ ಆಗೋಕ್ಕೆ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಟೈಮ್ ತೊಗೊಳತ್ತೆ, ಬಿಕಾಸ್ ಆಫ್ ದ ಟೈಮ್ ಟೇಕನ್ ಬೈ ದ ಸಿಗ್ನಲ್ ಟು ಟ್ರಾವೆಲ್ ಫ್ರಮ್ ದ ಸ್ಯಾಟಿಲೈಟ್ ಟು ಗ್ರೌಂಡ್. ಬಟ್ ದ ಅಡ್ವಾಂಟೇಜ್ ಇಸ್ ದ್ಯಾಟ್ ಇಟ್ ಕ್ಯಾನ್ ಕವರ್ ಅ ಲಾರ್ಜರ್ ಏರಿಯಾ, ರಿಮೋಟ್ ಏರಿಯಾಸ್ಗೆ ಇಂಟರ್ನೆಟ್ ಪ್ರೊವೈಡ್ ಮಾಡ್ಬೋದು. ಮತ್ತು ಇವಾಗ ಸೀಸಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಫಾರ್ ಮಿಲಿಟರಿ ಪರ್ಪಸ್ ಆ್ಯಂಡ್ ಆಲ್ ಆಫ್ ದಟ್, ದೇ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಇಂಟರ್ನೆಟ್. And also in aeroplanes we can have this internet if it is directly from the satellite. So it will not interfere with this radio signals. So that is one advantage of having this satellite internet system. So this is still a project that has to be implemented, and Starlink is one project that is they are planning to do this satellite internet system. And there is another company also, OneWeb anta, they also planning to do this satellite internet system. So you can write about satellite internet. Wireless internet beamed down from satellites orbiting the earth, instead of optical fiber. So the drawback is it requires a clear line of sight. To the satellite, and higher latency due to the time taken by signals to travel from space to earth. time taken by signals to travel from space to Earth. So Starlink, I already told, they're planning to place around 42,000 satellites, small satellites in the low Earth orbit, okay, so that they can have wireless internet. You can write a line about Starlink project. Developed by SpaceX, to provide high speed internet, developed by SpaceX to provide high speed internet to remote locations, Satellites are placed in low Earth orbit and SpaceX plans to have 42,000 satellites. SpaceX plans to have 42,000 satellites. So next we will see some important global space missions. So Luna series is by USSR, okay, Luna 3, 1, 2, 3, illa USSR, Russia dadu. It is the Luna satellites of Russia. And ಈ ಅಪೋಲೋ ಸೀರೀಸ್ ಬಂದು ನಾಸಾದು and Apollo 11 is believed that NASA landed on the moon and Neil Armstrong actually walked on the moon, and some people say it that it's a hoax, just ಅವಾಗ ಯಾಕಂದರೆ USA ಮತ್ತು USSR ಮಧ್ಯ there was Cold War happening, and if USA had proved that it landed on the moon, that gives more edge to USA anta. Some people tell that NASA didn't actually land on moon, that it was artificially created on all of that. They're still not sure. There are theories that it was fake, but we never know whether it was fake or actually they landed. Because even one thing I feel that, but if NASA already landed on the moon in 1969, then why it took so long for NASA to go back on the moon again is the question that I have. But again, they are now planning to send in this Artemis mission that they have, sending people back on the moon. Probably now it is possible, now they can achieve. But in 1969, we don't know whether it was true or not, but it is believed that Neil Armstrong landed on the moon in the Apollo 11 satellite spacecraft. And then Chang'e is China's. Chang'e series ಏನೇನು ಬರುತ್ತೆ, that is all China's only. India's Chandrayaan series. And Japan also has this one mission, Hiten anta, adu bandi to moon. So mainly lunar missions andre you just have to know the name and ಯಾವ countryದು ಅಂತ. Particular missions ಗೊತ್ತಿರೋದು ಬೇರೆ countryದು, it is not that important. ಇವಾಗ ಲೂನಾ ಬಂದು USSR ರಷ್ಯಾದಂತ ಗೊತ್ತಿದೆ, that is enough. And this USAS is Apollo series, and now they have Artemis, that is in the next upcoming Artemis missions ಇದೆ. ಅದಾದಮೇಲೆ China's is Chang'e and India's is Chandrayaan. ಈ 4 ಕಂಟ್ರಿದು ಮೇನ್ ಆಗಿ ಹೆಸರು ಗೊತ್ತಿದ್ರೆ that is enough. You don't have to know the specific space missions, because that is all in the past. The questions will be asked that is upcoming space missions only. Okay. So let us see this first Artemis mission. So Artemis mission, it is a joint initiative of NASA, ESA, that is European Space Agency, JAXA and Canadian Space Agency. So Artemis is combination of all four space agencies. And Artemis 1 was the uncrewed space mission, okay, that that went around the moon. It was launched in 2022. So it was uncrewed, just lange one space mission kalsidu which orbited around the moon. And Artemis 2 is they are planning to fly by the moon. So astronauts are going to go around the lunar orbit and then come back to Earth. So this is going to take place probably in 2026 or 2027, sometime there. And Artemis 3 is where they are going to land on the moon, and that will be in 2027 or beyond that, maybe around 2030 it might take. So they are telling that they are going to land first women and first non-white astronaut. So because that USA has to be prove that it's not racial and all of that, so they are planning to send first women and non-white astronaut to land on the moon's surface. And Artemis 4 is where they are going to have a space station in lunar orbit. Like how we have a space station in Earth orbital and international space station idella. So similarly lunar orbitally one space station irbeku, yakandre it will be easier for us to go to the Mars, because if we go from there, if we launch a satellite from the moon, because we can make use of the gravitational force of the Earth, so that it will push the Earth, push the spacecraft even faster. It will give an edge for the rocket to go faster and can land on the Mars surface. So that's why they are going to have a space station in the lunar orbit. So that is Artemis 4, and it will take more time, probably in the 2030s or sometime it will happen. So you can write about Artemis, joint mission of NASA, ESA, that is European Space Agency, CSA, Canadian Space Agency, and JAXA, that is Japan's space agency. So Artemis 1 launched in 2022. Uncrewed test flight around the moon. Uncrewed test flight around the moon. Artemis 2. Artemis 1 was uncrewed test flight around the moon. The Artemis 2 to fly astronauts around the moon and back to Earth. To fly astronauts around the moon and back to Earth. Artemis 3 land humans near the lunar south pole. Land humans near the lunar south pole. And Artemis 4 to have a space station in lunar orbit. Space station in the lunar orbit. So that is about Artemis. Then we have JUICE, Jupiter Icy Moons Explorer Mission. So this was launched in 2023 by European Space Agency. It was launched in 2023 by European Space Agency. So this mission is going to study the Jupiter's moon. Jupiter, Jupiter has around nearly 94 moons or something, 94 known moons. So Earth has only one, but Jupiter has 94 moons. And adali 4 moon bandi tumba important. It is bigger ones. So one is Callisto, Europa, and this Ganymede. I think it is very. So Callisto, Europa, and Ganymede, and the other one is Io. So these are the 4 big moons of Jupiter. So this JUICE mission is going to study these 3 moons of the Jupiter. So it was launched in 2023 and it is going to reach near the Jupiter by 2031, because it is very far from Earth. The spacecraft has to travel such a long distance, so it will reach by 2031. Okay. So you can write about this. See, once it is given, it escapes the gravitational, pull of the Earth. There is some escape velocity. So once that spacecraft goes out of it, so they will, set the direction for the spacecraft initially. Okay, and it will keep on moving. So any object in the universe, once it out of the gravitational pull, it keeps on moving. The Newton's first law of motion basically. Any object will be in a state of motion or rest unless and until external force is applied on it. So based on this Newton, it will keep on moving in the universe. So we have other spacecrafts also that went beyond this Pluto. So that's how we got to know about Pluto, the Kuiper belt and all of it. Voyager anta, it was sent by NASA only. So this kept on going, it will keep moving in the universe. So they will keep a trajectory on which direction the spacecraft has to move, and when it is out of the gravitational pull of the Earth, it will keep on moving towards the Jupiter. Okay. So this is a mission to study Jupiter's 3 largest icy moon, 3 largest icy moons, that is Callisto, Europa and Ganymede. So the spacecraft will reach near the near the Jupiter in 2031. In 2031. So ಯಾವ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ ಲಾಂಚ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ, ಎಕ್ಸಾಮಲ್ಲಿ ಆ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳೋದು. ಸೊ ಇದು ಯುರೋಪಿಯನ್ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ, ನಾಸಾ ಅಲ್ಲ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಟ್ ದಿಸ್ JUICE ಮಿಷನ್ ವಾಸ್ ಲಾಂಚ್ಡ್ ಬೈ ದ ಯುರೋಪಿಯನ್ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ. So next we have this Psyche mission. It is by NASA. It was launched in 2023. So this is going to explore an asteroid in the asteroid belt. So the asteroid is named actually Psyche because this asteroid is made up of this iron and nickel. The asteroid is made up of iron and nickel, and studying this asteroid will give us information about the Earth's core, because Earth's core also contains this nickel and iron and all of that heavier metals, right. So, this will provide information about the Earth's core. For us, it is not possible to go deep down in the Earth's core and explore what Earth is actually made up of. But these external objects will give information about the Earth's core. So, that is why this mission is aimed at, for knowing about the Earth's core. Okay. This is a Psyche named asteroid that is there in the asteroid belt between Mars and Jupiter. So, Psyche mission launched by NASA in 2023 at Berkeley. It aims to explore a asteroid called Psyche, located between Mars and Jupiter, located between Mars and Jupiter. It is believed to be composed of iron and nickel. It is believed to be composed of iron and nickel, which could provide insights into the composition of Earth's core. Composition of the Earth's core. DART mission. So, DART mission is also NASA's only, NASA dene idu no. So, idenandre it is like a defense satellite which will destroy asteroids that is going to come near the Earth. So, probably asteroid which can enter the Earth, no, adu Earth mele impact agutte. So, any asteroid that come near the Earth, it will destroy it basically, a defense mechanism tara this DART mission has been made. So, it will deflect the either if it is small, it will deflect the asteroid away from the Earth, or it will completely destroy it, so that it not enter the Earth's atmosphere. Okay. So, DART, double asteroid, full form andi double asteroid redirection test. It is by NASA. First ever test of a planetary defense technique, to deflect an asteroid. Okay, that is about DART mission. And it was launched in 2022. So, this Punch mission is also by NASA only. So, this is placed in the low Earth orbit. It is placed in the low Earth orbit and it was launched in 2025. Launched in 2025. So, it is comprised of 4 smaller satellites that is placed in a low Earth orbit, which will study about the sun's corona basically. Again solar window, a coronal mass ejection, ಅದರ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡೋದಕ್ಕೇನೆ ಈ ಪಂಚ್ ಮಿಷನ್ ಇರೋದು. ಇಟ್ ವಾಸ್ ಲಾಂಚ್ ರೀಸೆಂಟ್ಲಿ, ಸೊ ದಟ್ ಇಸ್ ವೈ ದಿಸ್ ವಿಲ್ ಬಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ it is a mission by NASA launched in 2025. It uses 4 small satellites to image the sun's corona, and to study about the space weather. So, the full form of PUNCH is polarimeter to unify the corona and heliosphere. Heliosphere. So, heliosphere andre ontara bubble like space that is created by the sun. Okay, sun's coronal mass ejection adaga ontara bubble like space create aguttalla, adna heliosphere anta kariತೀವಿ. It is a giant bubble like region of space created by the sun's outward flow. ಅದನ್ನು ಹೀಲಿಯೋಸ್ಪಿಯರ್ ಅಂತ ಹೇಳ್ತೇವೆ. So, International Space Station. So, International Space Station was a global partnership between NASA, Roscosmos ಅಂದರೆ ರಷ್ಯಾದು, ಆಮೇಲೆ ESA, JAXA ಮತ್ತು CSA, 5 countries involved. ಇಸ್ರೋ ಇಲ್ಲ. ಸೊ ಇದು it is placed in the low Earth orbit only, International Space Station, and by 2030 they are planning to retire this International Space Station. Okay, they are going to send a new one. And India is planning to do its own space station in the low Earth orbit, that is Bharatiya Antariksha Station, and they are going to do it by 2030 is what the plan is. So, but it will extend for a few more years. So, International Space Station ಯಾವ countries ಇದೆ ಅಂತ ಬರ್ಕೊಂಡ್ರೆ that is enough. You write it is a global partnership of NASA, ESA, JAXA and CSA ಮತ್ತೆ Roscosmos. ಅದು ಬಂದು Roscosmos by Russia Space Agency, it is called as Roscosmos. It is very difficult to be in the space. They usually once hodre at least 6 months they will spend in the International Space Station, and they'll daily have to exercise to keep their bones properly, because ಅಲ್ಲಿ microgravity ಇರುತ್ತೆ. ಅಂದರೆ ಪ್ರಾಪರ್ ಗ್ರಾವಿಟಿ ಇರೋದಿಲ್ಲ, ಜಸ್ಟ್ ಮೈಕ್ರೋಗ್ರಾವಿಟಿ. ದೇ ವಿಲ್ ಬಿ ಫ್ಲೋಟಿಂಗ್ ಇನ್ ದ ಸ್ಪೇಸ್ ಸ್ಟೇಷನ್ ಆ್ಯಂಡ್ ದೇ ವಿಲ್ ಹ್ಯಾವ್ ಅ ಲಾಟ್ ಆಫ್ ಮಸಲ್ ಲಾಸ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ದೇ ವಿಲ್ ನೋ ಪ್ರಾಪರ್ ಫುಡ್ ಇಂಟೇಕ್ ಇರೋದಿಲ್ಲ. Because of the microgravity there will be muscle loss, and for them, you know, to come and adapt to this gravity, it will take some time for them to, because ಇಲ್ಲಿ full gravity ಇರುತ್ತೆ, they will be used to that microgravity environment, and suddenly coming here it will be a different change. There was one interview of this astronaut who was in International Space Station, you know. He was writing something and he used to, you know, leave the pen like this only, and every time it used to fall because he was still on thara in a microgravity alli irange, because alli float agutte. So any pen or anything that you leave, it's going to float over there. But here it's not like that. So, you know, he used to write and he used to leave it like that in air alli, and it used to fall. No, that is very difficult for them to come back here, adapt to this gravity again. So it is very challenging. And so many of Indian astronauts have also been to Indian origin astronauts, like Rakesh Sharma, Kalpana Chawla, and Sunita Williams. So she recently also went to the International Space Station, you know, but her stay extended. She was supposed to come back, but you know, technical error in the, she stayed for more time there in the space. And that video and all was viral at that time of her. She had recorded a video and all of that. So next, important telescopes. So GMRT is Giant Meter Wave Radio Telescope. This Giant Meter Wave Radio Telescope. So it is located in Pune, Maharashtra. This GMRT is located in Pune, Maharashtra. So illi you can see that big antennas, right? There are 30 such, like, you know, parabolic radio telescopes. So it is going to take the radio signals, you know, coming from the universe, and then they will convert it into data, so that data can be processed to study. So we have a separate division called as radio astronomy. So where they are going to study only about the radio waves and where the radio waves are coming from and all of that. So most of this astronomical studies, you know, they are just doing this data analysis. All the data that they are getting from the satellite, they are going to analyze it. There will be certain tools to analyze this data, and they will get to know from where these radio signals are coming from and all of that. So this is an array of parabolic radio telescopes. It is present in Pune. Okay. So GMRT, that is Giant Meter Wave Radio Telescope. It is array of 30 parabolic radio telescopes spread over 25 kilometer area. And it is located in Pune, Maharashtra. Okay. So next we have this 30-meter telescope. 30 meters telescope, and it is located in Mauna Kea, Hawaii, USA hatra, Mauna Kea. So it is a 30-meter telescope. So it is a huge, very big telescope. And ಏನಕ್ಕೆ ಹವಾಯಿ ಅಂದರೆ it is an island off coast of USA. So it is very remote, light pollution ತುಂಬ ಕಡಿಮೆ ಇರುತ್ತೆ. So that's why they've chosen that place. So it is important that any telescope light pollution should be very less. ಅವಾಗಲೇ ನಾವು ಸ್ಕೈನ ಅಬ್ಸರ್ವ್ ಮಾಡೋಕ್ಕಾಗೋದು. So there is this one observatory in Kavlur ಅಂತ, it's near to Bangalore in Tamil Nadu ಅಲ್ಲಿರೋದು, Kavlur observatory ಅಂತ. There is one telescope there, and that location around 120 kilometer radius ಗೆ ಯಾವುದು light pollution ಇರಲ್ಲ. And any small villages ಏನಾದರೂ ಇದ್ದರೆ after certain time they're not supposed to switch on any lights in their homes, because it will be observing the sky, and there should be minimal light pollution over there. So this is 30-meter telescope present in Mauna Kea, and it will look in the optical, like visible light, and also in the infrared, both visible and infrared observatory. It is visible and infrared observatory, and it is a joint initiative of USA, Japan, Canada, China and India. USA, Japan, China, Canada and India. So in 1 year, at least like a week or some time, they will give that this telescope for the Indian astronomers to study about it. So they can get the data from that telescope, whatever data, and they can process that data to study about the universe. It's like that. So on ಸ್ವಲ್ಪ period of time ಗೆ they will give it to Indian astronomers, can go there, work there in that observatory. So next we have Euclid Space Telescope. ಇದು ಬಂದು ಯುರೋಪಿಯನ್ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ, ಇದು ESA, ಯುರೋಪಿಯನ್ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ ಇದು, and it is at the Lagrange point L2. It is at the Lagrange point L2, that is behind the earth. Okay. So it gives it looks directly into the universe, uninterrupted view irutte namge. Better understanding of the universe we can do with this space telescopes. So ಇದು Euclid Space Telescope, ESA ಇದು, to study about universe, about something called as dark matter and dark energy. So dark matter, dark energy andre something that is unknown to us, a matter that we cannot see, an energy that we don't know about. So there is some energy that is there in the universe that we still don't know about. Namge 4 fundamental energies gottu. So adna bitti there is this some other energy that is driving the universe, and we have to unlock it. So that is why we are going to study so much about ಏನಕ್ಕೆ ಇಷ್ಟು ಸ್ಪೇಸ್ ಮಿಷನ್ಸ್ ಎಲ್ಲ ಕಳಿಸ್ತೀವಿ ಅಂದರೆ ಟು ನೋ ಅಬೌಟ್ ವಾಟ್ ಇಸ್ ದಟ್ ಎನರ್ಜಿ ಅಂತ. ಸೊ ಡಾರ್ಕ್ ಎನರ್ಜಿ, ಡಾರ್ಕ್ ಮ್ಯಾಟರ್ ಅಂದರೆ ಸಮಥಿಂಗ್ ದಟ್ ವಿ ಡೋಂಟ್ ನೋ ಅಬೌಟ್ ಅಂತ, ಆ್ಯಂಡ್ ವಿ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಸ್ಟಡಿ ಅಬೌಟ್ ಇಟ್. Okay, so this Euclid space mission is going to study about this dark matter and dark energy. Then we have this Event Horizon Telescope. Event Horizon Telescope andre idunu ground based telescope, it is present on the earth. There is 8 telescopes in different regions. Yav region andre it is, one is present in Hawaii, Arizona, that is there in USA only, and then Chile. Chile, it is a country in South America. ಮತ್ತೆ ಮೆಕ್ಸಿಕೋ ಇದೆ, and there is also one in Spain. Like one alla, there are like totally 8 radio telescopes located at these many locations, different countries alli. So since it is there at different location, you know, it all works together simultaneously, ಒಟ್ಟಿಗೆ work ಆಗುತ್ತೆ, so that you know it behaves like this. All 8 telescopes is one huge radio telescope ತರ, because it is working together. Okay, it behaves like one huge radio telescope. So this was the one which captured this black hole image. Event Horizon Telescope only captured the black hole image in 2019. Okay, so you can write that. Did you write it is a network of 8 telescopes there, and in these places, and it captured first ever picture of black hole in 2019. And this is a radio telescope. This is a radio telescope. ಯಾವ electromagnetic spectrum ಅಲ್ಲಿ the telescope is working ಅನ್ನೋದು it will be important. Radio telescope. Then we have the they will actually stimulate it, ಡೇಟಾನ ಇಟ್ಕೊಂಡು ಸ್ಟಿಮ್ಯುಲೇಟ್ ಮಾಡ್ತಾರೆ. Then we have the Hubble Space Telescope. So it was launched by NASA and ESA in 1990 in the low Earth orbit. Idu low Earth orbit alli ittu Hubble Space Telescope. But now it is retired. Hubble Space Telescope is retired, and its replacement was the James Webb Space Telescope. It was used for deep sky observations. It was used for deep sky observations. In visible and ultraviolet. So it was in the visible and ultraviolet wavelength. You all right this one. So next is the James Webb Space Telescope. So it was launched in 2021. NASA, ESA and Canadian Space Agency collaborative idu. And it is placed at Lagrange point L2. Lagrange point L2, that is behind the earth only. So this observes in infrared IR, okay, infrared wavelength. Matte idunu same for deep sky observation only, okay. It is used for the deep sky observation. So this question was asked in the UPSC. James Webb Space Telescope ಯಾವ electromagnetic spectrum use ಮಾಡುತ್ತೆ ಅಂತ. So it was asked in 2019 2023 exam. So, you know, anything that comes in news, ಈ ಥರ ಅದು ಹೊಸ ಸ್ಯಾಟಲೈಟ್ ಅಥವಾ ಹೊಸ ಸ್ಪೇಸ್ ಕ್ರಾಫ್ಟ್ ಸಮಥಿಂಗ್ ದೇ ಡೂಯಿಂಗ್, ಮೇನ್ ಆಗಿ ನೀವು ಅದಲ್ಲಿ ನೋಡಬೇಕಾಗಿರೋದು ಯಾವ ಸ್ಪೇಸ್ ಏಜೆನ್ಸೀಸ್ ಲಾಂಚ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ದಟ್ ವಿಲ್ ಬಿ ಇಂಪಾರ್ಟೆಂಟ್, ನಾಸಾ ಅಥವಾ ಇಸ್ರೋ ಇದೆ, ಇಸ್ರೋ ಎನಿ ಸ್ಪೇಸ್ ಏಜೆನ್ಸಿ, ಆ್ಯಂಡ್ ವಾಟ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಅಬೌಟ್. That will be important, what is the function of it and where it is placed. Like some satellites will be placed in low earth orbit, some will be there in geostationary, and some spacecraft, you know, it is kept at Lagrange points now. So yelli place agide, what is it is going to study, and who, you know, has launched that spacecraft or satellite, ಅದನ್ನು ನೋಡ್ಕೊಬೇಕು. ಸೊ ದೀಸ್ 3 ಪಾಯಿಂಟ್ಸ್ ವಿಲ್ ಬಿ, ನೀವು ಕರೆಂಟ್ ಅಫೇರ್ಸ್ ಓದಬೇಕಾದ್ರೂ ಇದನ್ನು ಮೈಂಡಲ್ಲಿ ಇಟ್ಕೊಂಡು ಓದಿ ಕರೆಂಟ್ ಅಫೇರ್ಸ್ನ. ಓಕೆ, so this is about the space technology. Almost covered most of it, but ನೀವು ಸ್ಪೇಸ್ ಮಿಷನ್ಸು ಅದು ಆ್ಯಡ್ ಆನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಒನ್ಸ್ ಯು ರೀಡ್ ದ ಕರೆಂಟ್ ಅಫೇರ್ಸ್ ಯು ನೀಡ್ ಟು ಆ್ಯಡ್ ಆನ್ ಫ್ರಮ್ ಇಟ್ ಇಫ್ ಐ ಮಿಸ್ ಸಮಥಿಂಗ್, ಬಟ್ ವಿಲ್ ಬಿ ದೇರ್ ಇನ್ ದ ನ್ಯೂಸ್. ಆ್ಯಂಡ್ ನ್ಯೂಸಿಂದಾನೇ ಯೂಶಲಿ ಸೈನ್ಸ್ ಆ್ಯಂಡ್ ಟೆಕ್ ಕ್ವೆಶನ್ಸ್ ಬರೋದು ಮೋಸ್ಟ್ ಆಫ್ ಇಟ್. ಮೇ ಬಿ 2 to 3 questions ವಿಲ್ ಕಮ್ ಫ್ರಮ್ ಬೇಸಿಕ್ಸ್. ಓಕೆ, ಸೊ ಅದರ್ಸ್ ವಿಲ್ ಬಿ ಮೋಸ್ಟ್ಲಿ ಫ್ರಮ್ ದ ನ್ಯೂಸ್ ಕರೆಂಟ್ ಅಫೇರ್ಸ್. ಸೊ ನೆಕ್ಸ್ಟ್ ವಿಲ್ ಸಿ ದಿಸ್ ನ್ಯೂಕ್ಲಿಯರ್ ಎನರ್ಜಿ. ಏನಾಯಿತು ಗಗನ್, ಬ್ರೇಕ್ ಬೇಕಾ ಮತ್ತೆ? Okay. So nuclear energy is nothing but the energy stored in the nucleus of an atom. So if fission process adaga, nuclear fission adaga, you know, there will be enormous amount of energy will be released in that process. Okay. So namge nucleus of an atom alli there is nucleus and there is neutrons and protons, and electrons will be revolving around the nucleus. Okay. So any atom if we take centrally neutron plus protons irutte, and around the nucleus there will be something called as shells, and electrons will be orbiting. So electrons will be orbiting around the nucleus, and number of protons present in an atom, so that will give us the atomic number. Okay, number of protons plus neutrons will give us atomic mass number. Okay, so this we will again see in chemistry. Okay, chemistry bandaga again we will study about this. So in nuclear fission process alli ಏನಾಗುತ್ತೆ, so there is one heavier nucleus. Okay, so ಇದು unstable ಆಗಿರುತ್ತೆ. So you know that is what we call it as radioactive elements. So the radioactive elements andre the elements which are unstable. So stable ಆಗಿರಲ್ಲ, and you know that atom has to come to stable form, stability ಗೆ ಬರಬೇಕು. So ಆವಾಗ ಅದು ಡಿಕೆ ಆಗೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So you know when a neutron come and hits this nucleus, okay, this atom, so this atom idu split ಆಗುತ್ತೆ. So uranium 235 ತಗೊಂಡಿದ್ದಾರೆ ಇಲ್ಲಿ, so it will split into barium and krypton. So ನಾವು ಒಂದಷ್ಟು ಯುರೇನಿಯಂ ತಗೊಂತೀವಿ ಅಂದರೆ it consists of so many atoms, right? So when one fast neutron hits it, it split. So until everything achieves this stable state. So, all of the atoms present in it must achieve the stable state. Ali tanka ee fission reaction will keep on happening. Okay. So, idralli ee process alli enormous amount of energy will be released and a free neutrons will also be released. Along with this, there will be this alpha, beta and gamma radiations will be released in this process. So, gamma bandi it will be a very high energy radiation. So, adine ನಾವು radioactive decay ಅನ್ನೋದು. So, radioactive element which is in the unstable state has to come to a stable state. So, ಅವಾಗ ಏನಾಗುತ್ತೆ it will decay, it will split to form lighter nucleus. ಅದನ್ನೇ ನಾವು nuclear fission reaction ಅಂತ ಕರೆಯೋದು. So, ಈ process ಅಲ್ಲಿ enormous amount of energy will be released. So, that energy can be made used to produce electricity. So, it will be a cleaner fuel, it will be a clean fuel because it is renewable source and extra carbon dioxide nothing will be released. But it is a radioactive element and radioactive elements have this radiations which may cause some effects on human. So, ಈ radioactive waste ಏನಿದೆ ಅದನ್ನ ನಾವು carefully dispose ಮಾಡಿದ್ರೆ then we can make use of this nuclear energy. So, this will revolutionize of how we are using energy right now. So, it can be used to produce electricity and all of that. So, nuclear fusion alli enagutte two lighter atoms are combining to form one heavy atom. Okay, idu ನಾವು ನೋಡಿದ್ವಿ sun ಅಥವಾ stars ಅಲ್ಲಿ the interior, the core of the stars ಅಲ್ಲಿ nuclear fusion is happening. So, allunu enormous amount of energy is released, but it is very difficult to achieve this fusion here on earth. It requires very high temperature, ತುಂಬಾ ಜಾಸ್ತಿ temperature ಇರಬೇಕು for fusion to happen. Okay. So, fusion kuda they are doing it now, this tokamak reactors anta ide where they are using nuclear fusion technology to produce this energy. Okay. But fission is where we are currently using right now and in all of this nuclear reactors alalla ee fission reaction ine use ಮಾಡ್ತಾ ಇರೋದು ನಾವು right now. Okay. So, this is about nuclear fusion and fission. So, you can write one line about nuclear fission and fusion. It involves disintegrating a heavy atom, fission. Nuclear fission, it involves disintegrating a heavy atom into two or more smaller nuclei. Example you can take as uranium, plutonium, these are radioactive elements. So, this is an example. So, nuclear fusion, next barkoli, nuclear fusion, the process of combining two or more nuclei to form a heavier nucleus. This naturally occurs in stars. At the core where temperature is very high. where temperature is very high. So this nuclear fission is also used in this atomic bomb. Nuclear bombs anta navenu karitivi. So the fission reaction is used there. So this Japan mele Hiroshima Nagasaki mele hakiddu, there is atomic bombs that was developed by the USA. So a person called as Oppenheimer, yes, Oppenheimer, Robert Oppenheimer. So he was the mastermind behind this nuclear bomb. Alli fission reaction ಆಗುತ್ತೆ. ಮತ್ತೆ we have hydrogen bomb ಅಂತ ಇದೆ, but that is not yet developed, or it's an idea like it works on the principle of nuclear fusion. Okay. So first fission ಆಗುತ್ತೆ, hydrogen bomb ಅಲ್ಲೂ first fission ಆಗುತ್ತೆ, then that fission will help in the nuclear fusion. That is more destructive, like ತುಂಬಾ large scale destruction ಮಾಡ್ಬೋದು with using hydrogen bomb, because fusion ಅಲ್ಲಿ ತುಂಬಾ enormous amount of energy release ಆಗುತ್ತೆ, because it needs very high temperature condition ಬೇಕಾಗಿರೋದ್ರಿಂದ ತುಂಬಾ ಜಾಸ್ತಿ energy will be released and large scale destruction ಆಗುತ್ತೆ. Fission also, it is a large scale destruction. We saw what happened in Hiroshima and Nagasaki, right? So that is also very destructive. So illi for the nuclear fusion to happen, we need something called as fissile material, which can undergo fission very quickly. Something called as fissile material. So ivaga ನಾವು ಒಂದು ಫಾಸ್ಟ್ ಮೂವಿಂಗ್ ನ್ಯೂಟ್ರಾನ್ ನ ಈ ಫಿಸೈಲ್ ಮೆಟೀರಿಯಲ್ ಗೆ ಹಿಟ್ ಆಯಿತು ಅಂದರೆ ದೆನ್ ಇಟ್ ವಿಲ್ ಅಂಡರ್ಗೋ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಷನ್ ರಿಯಾಕ್ಷನ್. ಸೊ ಆ ಫಿಸೈಲ್ ಮೆಟೀರಿಯಲ್ಸ್ ಯಾವ್ದ್ಯಾವುದು ಅಂದರೆ ಯುರೇನಿಯಂ 235 and uranium 233 and plutonium 239. So these are the fissile materials. ಅಂದರೆ ಇವಾಗ ಒನ್ ಫಾಸ್ಟ್ ಮೂವಿಂಗ್ ನ್ಯೂಟ್ರಾನ್ ಬಂದು ಇದ ಮೇಲೆ ಹಿಟ್ ಆದರೆ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಷನ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಹ್ಯಾಪನಿಂಗ್. ಓಕೆ, ಸೊ ದೇರ್ ಇಸ್ ಯುರೇನಿಯಂ 235, ಯುರೇನಿಯಂ 233 ಅಂತ ಇದೆಯಲ್ಲ, ಸೊ ಇದನ್ನು ನಾವು ಐಸೋಟೋಪ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಿ ಕಾಲ್ ದಿಸ್ ಆಸ್ isotopes. So isotopes andre it has same number of protons but different number of neutrons in the nucleus. Okay, same number of protons but different neutrons irutte. So atoms ನಾವು isotopes ಅಂತ ಕರಿತೀವಿ. So example, even this carbon has isotopes, carbon 12, carbon 14. So ಅದೇ ಥರ uranium also, uranium 238, uranium 235, uranium 233. So ಇದೆಲ್ಲ isotopes. It has same number of protons but different number of neutrons in the atoms. Okay. So these are fissile materials which are required for nuclear fission to take place. ನಾವು ಇವಾಗ ನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಟರ್ಸಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಸೊ ನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಟರ್ಸಲ್ಲಿ ಕಂಟ್ರೋಲ್ಡ್ ಇರುತ್ತೆ. ಸೊ ದ ಫಿಷನ್ ರಿಯಾಕ್ಷನ್ ಏನಾಗ್ತಾ ಇದೆ ಇದು ಕಂಟ್ರೋಲ್ ಮಾಡ್ತೀವಿ ನಾವು, ಸೊ ದಟ್ ಇದು ಚೈನ್ ಕಂಟಿನ್ಯೂ ಆಗಲ್ಲ. ಇಫ್ ಇಟ್ ಈಸ್ ಅನ್ಕಂಟ್ರೋಲ್ಡ್ ಆವಾಗಲೇ ಅದು ನ್ಯೂಕ್ಲಿಯರ್ ಬಾಂಬ್ ಆಗೋದು, ಅಟಾಮಿಕ್ ಬಾಂಬ್. ಅನ್ಕಂಟ್ರೋಲ್ಡ್ ಆದರೆ ಇಟ್ ವಿಲ್ ಎಂಡ್ ಅಪ್ ಇನ್ ಅ ಹ್ಯೂಜ್ ಎಕ್ಸ್ಪ್ಲೋಷನ್, ದೆನ್ ದ್ಯಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ನ್ಯೂಕ್ಲಿಯರ್ ಬಾಂಬ್ or atomic bomb we call it as. But controlled ಇದ್ರೆ ನಾವು ಈ ಎನರ್ಜಿ ಏನು ರಿಲೀಸ್ ಆಗುತ್ತೆ ಈ ಎನರ್ಜಿನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಅಬೌಟ್ ದಿಸ್ ಫಿಸೈಲ್ ಮೆಟೀರಿಯಲ್ ಫಸ್ಟ್. Fissile isotopes readily undergo nuclear fission when hit by neutrons, releasing enormous amount of energy, Example bandi uranium 235, uranium 233, plutonium 239. Okay. So isotopes andre you can just write it, it has same number of protons but different number of neutrons anta. You can just write it somewhere. So but for us, you know, the naturally occurring uranium, natural uranium namge abundance ಅಲ್ಲಿ ಸಿಗೋದು ಬಂದು uranium 235. So uranium 235 only is naturally occurring. But ಅದರಲ್ಲಿ ನಮಗೆ uranium 238 is naturally occurring. Okay, uranium 238 is naturally occurring. But ಅದು readily fissile material ಆಗಿ ನಾವು ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಯಾಕಂದರೆ when it is hit by a neutron it will not undergo fission. Uranium 238 ಇದ್ರೆ. So that is why we need uranium 235 to undergo fission reaction. ಸೊ ನಾವು ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ, ನ್ಯಾಚುರಲಿ ಅಕರಿಂಗ್ ಯುರೇನಿಯಂ ಏನಿದೆ ಅದನ್ನ ನಾವು ಎನ್ರಿಚ್ ಮಾಡ್ತೀವಿ. ಯುನೋ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಎನ್ರಿಚ್, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಪ್ರೇಟ್ ದಿಸ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಆ್ಯಂಡ್ ಪ್ರೋಟಾನ್ಸ್ ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಗೆಟ್ ಮೋರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಯುರೇನಿಯಂ 235. ಸೊ ಇದು ಎಷ್ಟು ಗೊತ್ತಾ, ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 0.7% ಇರುತ್ತೆ ಯುರೇನಿಯಂ 238ಅಲ್ಲಿ. ಯುರೇನಿಯಂ 235 ವಿಲ್ ಬಿ ಓನ್ಲಿ 0.7%. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು enrich that to 3 to 5% so that we can use it in the nuclear reactors. Nuclear reactors ಅಲ್ಲಿ ನಾವು ಯುರೇನಿಯಂ 235ನ ಯೂಸ್ ಮಾಡ್ಬೋದು, ಯಾಕಂದರೆ ಅದು ಮಾತ್ರ ರೆಡಿಲಿ ಇಟ್ ವಿಲ್ ಅಂಡರ್ಗೋ ಫಿಷನ್ ರಿಯಾಕ್ಷನ್. ಯುರೇನಿಯಂ 238 ಬಂದು ಫಿಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗೋಕ್ಕಾಗೋದಿಲ್ಲ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಈಸ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು enrich uranium 238 to get more concentration of uranium 235. ಸೊ ಇದರಲ್ಲಿ ಹೆಂಗೆ ಎನ್ರಿಚ್ ಮಾಡ್ತಾರೆ ಅಂದರೆ ಥ್ರೂ ಅ ಪ್ರಾಸೆಸ್ ಕಾಲ್ಡ್ ಅ ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಸಪರೇಷನ್. ಸೊ ಅದೇನು ಪ್ರಾಸೆಸ್ ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಟು ವರಿ ಅಬೌಟ್ ದ್ಯಾಟ್, ಬಟ್ ಆ ಪ್ರೋಸೆಸ್ ಬಂದು ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಸಪರೇಷನ್. ಸೊ ದೇ ವಿಲ್ ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಅಂದರೆ ಏನು, ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಫೋರ್ಸ್ ಅಂದರೆ acts away from the center. So acts towards the center ಬಂದು ಸೆಂಟ್ರಿಪೀಟಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಅಂದರೆ acts away from the center. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ we are going to use the centrifugal separation so that higher concentration of uranium 235 will come in the center and that can be used in the nuclear reactors so that it will directly undergo nuclear fission ಅಂತ. So that is enrichment of uranium. So you can write uranium enrichment anta. Uranium enrichment. Naturally occurring uranium, ಅದರ ಕೆಳಗಡೆ ಬರ್ಕೊಳ್ಳಿ, naturally occurring uranium. Bracket ಅಲ್ಲಿ you write it as uranium 238. Naturally occurring uranium, that is uranium 238 does not have enough concentration of uranium 235. So uranium 235, uranium enrichment is necessary. Uranium enrichment is necessary to have an effective nuclear fuel. to have an effective nuclear fuel. In enriched uranium, the percentage composition of uranium 235 has been increased from 0.7% to 3 to 5%. 3 to 5% through a process of centrifugal separation. ಸೊ ಈ ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಸಪರೇಷನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಯುರೇನಿಯಂ 238 ಇದೆ ಅಲ್ಲ, ಸೊ ದಟ್ ಈಸ್ ಆನ್ ಹೆವಿಯರ್ ಎಲಿಮೆಂಟ್, ದೇರ್ ಇಸ್ ಎ ಹೆವಿಯರ್ ಆಟಮ್. ಸೊ ಅದು ಬಂದು ಸೈಡ್ಸ್ಗೆ ಹೋಗ್ಬಿಡುತ್ತೆ ಟುವರ್ಡ್ಸ್ ದ ವಾಲ್. ಆ್ಯಂಡ್ ದ ಯುರೇನಿಯಂ 235 ಇಸ್ ಎ ಲೈಟರ್ ಆಟಮ್ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್ ಟುವರ್ಡ್ಸ್ ದ ಸೆಂಟರ್. ಸೊ ಅವಾಗ ಅದು ಎನ್ರಿಚ್ ಆಗುತ್ತೆ. ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಅನದರ್ ಮೆಟೀರಿಯಲ್ ಫಾರ್ ದ ಎನ್ರಿಚ್ಮೆಂಟ್ ಪ್ರಾಸೆಸ್. ಒಂದು ಮೆಟೀರಿಯಲ್ ಹಾಕ್ತಾರೆ ಯುರೇನಿಯಂ ಹೆಕ್ಸಾಫ್ಲೂರೈಡ್ ಅಂತ, ಅದಾಗದಾಗ ದಿಸ್ ವಿಲ್ ಎನ್ರಿಚ್. So that is, the process is not required how this separation has happened, but ನಾವು enrich ಮಾಡಬೇಕು because naturally occurring uranium ಅಲ್ಲಿ it cannot undergo fission process. ಸೊ ಅದಕ್ಕೆ ನಾವು enrich ಮಾಡಿದ್ರೆ ಅದು fission ಆಗೋಕ್ಕೆ it can be used as a fuel in the nuclear reactors. Okay. So components of a nuclear reactors, we will see this today, and next class we will see the type of nuclear reactors. A types on nodidre this nuclear technology is done, because there is only 20 minutes left, we will not be able to do that completely. And after that, next week doing the types of nuclear reactors, I will continue with biology, start with biology, okay, basics of biology, and then we will go forward with biotechnology. Okay. So here the components, main components andre this fuel rods. Okay, fuel rods alli enagirutte, there only your fuel uranium 235, uranium 233 or plutonium is used. Matte there is this controlled rods. Okay, controlled rods will be present, and then moderator irutte. Moderator, that is one important component, and this moderator ge cooling water ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ, water. Okay, to reduce the heat. Okay, so ಈ control rods ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ it will absorb the neutrons. ಸೊ ಇವಾಗ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಷನ್ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ನ್ಯೂಟ್ರಾನ್ಸ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಒನ್ ಟೈಮ್ ಫಿಷನ್ ಆದರೆ ದೇರ್ ವಿಲ್ ಬಿ ನ್ಯೂಟ್ರಾನ್ಸ್ ರಿಲೀಸ್ಡ್. ಸೊ ಆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ ಮತ್ತೆ ಹೋಗಿ ಬೇರೆ ಆಟಮ್ಗೆ ಹೋಗಿ ಹಿಟ್ ಆಗುತ್ತೆ. ಸೊ ಆವಾಗ ಮತ್ತೆ ಚೈನ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ ಅಗೇನ್, ದಟ್ ವಿಲ್ ಬಿ. ಸೊ ಅದನ್ನ ನಾವು ಕಂಟ್ರೋಲ್ ಮಾಡಬೇಕು. So we should control that chain reaction. Suppose control ಮಾಡಿಲ್ಲ ಅಂದರೆ ಅದು uncontrolled chain reaction ಆಗುತ್ತೆ, it will lead into explosion. ಸೊ ನಾವು ಎಕ್ಸ್ಪ್ಲೋಷನ್ ಆಗದೆ ಇರೋ ಥರ ಕಂಟ್ರೋಲ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ನಾವು ಈ ಕಂಟ್ರೋಲ್ಡ್ ರಾಡ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ವಿಚ್ ವಿಲ್ ಅಬ್ಸಾರ್ಬ್ ದ ನ್ಯೂಟ್ರಾನ್ಸ್. ಓಕೆ, ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಲೀಡ್ ಇನ್ ಟು ಫರ್ದರ್ fission, uncontrollable fission reaction ಆಗೋದಿಲ್ಲ. So this controlled rods are mainly made up of something called as cadmium anta. So we use cadmium to absorb this neutrons. And then we have this coolant, you know, the cooling water which will go here and which will cool the entire system basically. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, fission reaction ಆದಾಗ enormous amount of heat and energy will be produced, and that heat will be used to, you know, boil the water next to it. So ಈ water boil ಆದಾಗ steam produce ಆಗುತ್ತೆ ಅಲ್ಲ, so that steam is used to turn the turbine, and that will be converted into electrical energy. Okay, so the heat produced from this nuclear fission reaction will be used to boil the water next to it, so that steam produce ಆಗುತ್ತೆ. ಆ steam ಇಂದ ನಾವು ಟರ್ಬೈನ್ turn ಮಾಡ್ತೀವಿ. So when the turbine is turned, then the electricity will be produced, okay, or generated. So this cooling water will help to, it will provide water to this heating material, and also it will be sent to this reactor where it will be cooled. ಅಂದರೆ ಈ ಬೇರೆ ಕಾಂಪೋನೆಂಟ್ಸ್ ಎಲ್ಲ ಜಾಸ್ತಿ heat up ಆಗಬಾರ್ದು ಅಂದ್ಬಿಟ್ಟು we send this cooling material. So normally cooling material ಗೆ we use water only, okay, water only will be used. So these are the main components in the nuclear reactor, okay. So you can write key components of nuclear reactor. So first one is fuel rods. The core of the nuclear reactor, houses the fuel, ಅದೇ uranium 235, that is uranium 235 pellets. Nuclear reactor houses the fuel uranium 235 pellets contained in long thin metal tubes, called fuel rods. Then we have control rods. It is made up of materials that readily absorb neutrons, and example which in use ಮಾಡ್ತಾರೆ ಅಂದರೆ cadmium is mainly used as control rods. And we have coolant. It circulates through the reactor core. Absorbing heat, circulates throughout the reactor core, absorbing heat produced by ongoing nuclear chain, to prevent from overheating. And example is water is normally used. And after that you can write one line. The heat generated by the chain reaction, of the nuclear fission, produces steam. The heat generated by the nuclear reaction, by the chain reaction of nuclear fission, produces steam. This steam is used to move a turbine which generates electricity. So we'll stop it here, and we'll see the types of nuclear reactors, pressurized water reactors antalla ide. We have 4 types, fast breeders and all of that we'll see in the next class. Because if I continue, it will again take another more than 20 minutes to explain that. So we'll stop here. Thank you.